YouTubers, welcome. You missed me looking in every nook and cranny of this shop for a BMW E46 headlight switch. It's a part that I think is awesome. I think it would be really cool to have on the sim setup, and I put it aside somewhere, which means I lost it. I don't know where it is. I do not know. I have no fathom of where I put this thing. This switch would be really cool to have because it's got like a little thing for backlighting, and it headlights on and off, and you know, I kind of know the deal with it because it's the same one that my car has. I put it somewhere. We reverse engineered it ages ago, years ago. We reverse engineered it a little bit, and it works in the same way that all the stocks work, which is what we're going to work on today. I want to put a Mux, a device that basically flips a switch digitally, but this is an analog Mux, so it flips an analog output to a bunch of different pins. So you can basically take two, in the case of this one, you can take two analog pins and you can put it to 8 inputs. So you have 8 analog inputs that you can just peek in on and say, oh, that's what the value is. Because that's all the microcontroller is doing anyway. So if we set it up with a Mux and then I just hit a 1 and a 0 on 2 digital pins, I can flip between the 4 inputs and we can just check, you know, flip between the input, wait for it to settle, check the analog, flip between the input, wait for it to settle, check the analog. We can make that fast enough that I won't notice. You won't notice somebody pushing a button like this because microcontrollers work so fast that it's an unfathomable amount of time. It's like a fraction of a second. So that's what we're gonna take a look at. I wanted to find this headlight thing because it was gonna be an integral part of the sim setup. So I don't know what I did with it. I cannot figure out where I put the damn thing. I've got several stashes of parts and in other places. I've got tons of parts and project parts sitting back there. They're organized into bins per project, but then there's also sort of like an archive of storage that I've got somewhere around me, basically surrounding me right now. Surrounding me right now is all of these project parts. I remember running into it every now and then. The reason that I'm sweaty, you can see my glistening forehead, is that I've been reaching and groping and grasping all around the shop to try to get every single area that it might have fallen. At this point, I believe that I put it somewhere and then it fell from that location, and so it's probably dusty and lodged behind something. And I've been looking behind things all afternoon. It's how long? For an hour. I've been looking for it for an hour. This is what happens around here sometimes. I do not know where it is. So we're going to ignore it and we're going to work on the muxing stuff because it has worked itself into a place that I just can't comprehend right now. That or it's back behind stuff. I snuck it somewhere. I probably snuck it somewhere, right? I put it in something like a case that I can't quite get to all the time just to keep it safe. Archaeologists might be able to find it in the shop somewhere. My fear is that I did what I did with a lot of stuff. You'll find it in the bathroom. Maybe I'll remember where I put it in the bathroom. My fear is that this bin that sits above the face light here, that I chucked it in there, and so it would have fallen and gotten behind stuff, and then I can't see it. I don't think I did that. And you know, I looked all over this shelf and it's not there. I looked behind stuff here. I reached behind those things and found a bunch of stuff, a bunch of interesting stuff, but none of them were that switch. I have one. I have one of them, and it was a gift from a friend for helping him update his headlight switches. He got the European version, which have, I don't know, they got like an alternative thing that helps you do the headlight height. It's like a motor control. And so I'm left with the North American one, which I'm fine with, but it's gone. It's here. It's here somewhere. I will find it. I'll find it one day. I thought I had it like locally. I thought I had it like up here, but it's not. It's just not. I take one extra look over here just to make sure that I didn't miss it. Make sure that I didn't miss it. How has everyone's Friday been shaping up? It's Friday the 13th. It's Lucky Friday. Lucky Friday for all of us, you know? I hope you guys have a lucky Friday. You better have a lucky Friday. Okay, I don't know where it is. I thought it was all the way over here, but it's not. I thought it would have been here. Not behind or under the money gun. What's that? Oh, that's the monitor stand. My Subaru and Toyota both have the electronic headlight adjustment in the cabin. I always point them as low as possible. I don't have that adjustment, but my car actually has airbags in the back to level the headlights. So there's an extra little like arm on my suspension that measures the height of the rear. And if it's I put a bunch of cargo in the car and it weighs down the back, it'll inflate those airbags and lift so that the headlights are even. That's the level of care that they used to put into car headlights so that your halogens wouldn't blind people in the other lane. We have lost that technology, it seems, and are now in the dark ages of LED headlights that give you a spray tan as they pass by. You have a supernova just outside of your car, and when you flash them with the high beams, they hit you with the light bar as you simmer into pure carbon in your vehicle. I thought I put it here. I really thought I put it here. It is not. What up, Gunhead? How you doing? We're looking for that headlight switch. Do you remember that? Where did I put that? Tell me where I put it. I need to know. I'm looking for the headlight switch that I had for the BMW that it was going to be really cute to put with all the other simulator stuff. But we'll break from this in a minute, and we'll do microcontroller stuff because you know, that's my wheelhouse. That's more in my wheelhouse. As much as I know you guys love watching me flail around the shop fruitlessly looking for a thing. You don't remember it, probably. It was a long time ago and I keep talking about it, but I don't know what happened to it. I found a lot of weird stuff behind other things. I'm gonna look way deep down on the floor. Hold on. We're going deep. I'm getting under stuff. We're going into the no man's zone. I heard No Man's Sky got a big update, but it's like a demo for another game. All right, we're going to the no-no zone, chat. There. Got to move a 26-pound motor. All right, green screen. I got to get that back to the other room. That shouldn't be here. The shifter and my parking brake test. This is just a test. Could it be on your sim rig? No, I have some Velcro, some of that 3M Velcro stuff for it to attach to this, and it's not there. I think we found the back cover for it the other day. Or I might have found this with the back cover on it, but not the switch. Huh. That would mean that it fell off somewhere, which I'm not excited about. Did that fart go through, or I don't remember hearing it. And the other place that it could be is in these bins. These bins that I sort of... Sorry. Oh, I don't like sneezing into the microphone because then your speakers blow up. Glue goes back with glue. I mean, it could be on this shelf, but I thought we looked behind. Let me look behind here. This is like, because this switch uses the exact same methods to communicate what state it's in. It uses the multi-resistor voltage thing. So it's perfect for the setup that we're putting together today. Oh. I probably shouldn't be, I said I'd start up and then stop looking. I said this. I'm not living that reality. All right, giving up. I'll find it one day. I'm guessing it's in the other part of the shop. Oh yeah, I said I'd look under here. Hold on. I said I would look under here. Danger to the manifold, jammed farts. Oh my God. That's where that went. Oh well. It's a computer switch. Not over here. I cleaned under here recently, so I guess there really isn't anything. What is that? Some kind of fungus. Unfathomable. There's a whole ass Noctua fan just sitting back there. What's behind you? Ugh, hold on. Oh, the lens. Yeah, I don't see it. Fuck. I thought we'd be able to find it back there. I just thought, you know, I had a thought. I'm sorry. Oh my God, it's so disorganized. Ah! Okay, that's more organized now. I'm gonna sneeze again. All right, I'm coming back. Stream will start just a second. Ow, I really hit my finger on that. Did I get a splinter? No, okay. Smashing my hands on stuff because I'm not looking where I'm putting them. Yeah, I'm totally baffled. This is totally baffling. Wherever I put it, hopefully it's a safe spot, but I can't find it. I'm ready for that 4-hour search stream. I swear the last stream I watched, you had Switch in hand, but that was like a couple weeks ago at this point. Damn it. If only I knew. Did I really? I remember it vividly, which is why I thought it was on the top shelf here. But it isn't. And it's not behind a bunch of stuff. I looked behind things, I looked around things. All right, we got to give up. We got to give up. It's time to give up. It is time to give up. Assuredly, it is somewhere around here, and I probably put it in a spot. Probably put it in a little spot where I'd be like, yeah, I'll remember that's there. But at this point, I've looked behind so many things that I just don't know. I'm using this opportunity to just sit here in the fan. I'm just sitting here looking at the fan and cooling off, and hopefully not bursting into pure sweat. All right, nobody's commented yet on YouTube. I need to actually open the. Let's get YouTube chat on screen before somebody comes into YouTube and doesn't have a chat. Find and activate. There we go. Okay, cool. So now YouTube can be on screen too. Maybe I'm mistaken. Maybe I saw it on the desk right now. The one that's on the desk is already the K bus or whatever the BMW bus is. But this is the parking switch, which I have a parking lever. We could eventually incorporate this thing, but they're using smaller pins, and I don't really know what the pinout on this one is. So I wanted to get that big analog switch thing in because it's another couple channels of analog that can be incorporated into the steering wheel module. This is the module that's going to control all of the steering wheel control. So this thing, this like chicken wing shifter already speaks CAN bus, but it speaks the fast CAN bus. The motors for the steering wheel will have to be hooked up to motor controls and potentially controlled by this same module. So this module is going to go in and around the steering wheel, and it will control the up, down, right, and left. I'm going to just hit start soon here and get the music out of here. Wonk. Okay. Hi, how's it going? Welcome to my stream. I'm the sweaty and dust-covered bother. I have been looking everywhere for an old E46 2000s era BMW headlight switch. A friend of mine converted his M3 to the European switch, which allows you to have height control, which I guess was against regulations at the time in North America. And so the North American one does not have this extra control. I was left with the old hardware because I kind of helped. He had to do something with soldering, so he brought it over here and he gave me the old parts. That would have been perfect for this sim setup because then I have a switch that's right next to the wheel that would turn on the headlights and do the backlighting amount. It's got a little one of these things for doing the backlight. And so I could have had that initiate the backlight packet to the rest of the CAN bus stuff, and the things that do have backlighting could, you know, turn on the backlighting. I've been looking everywhere for it. We haven't found it. I don't know what happened to it. Part of it was stuck to my desk clamping steering wheel setup, which means it might have hit up against something and fallen off, because that thing's like 20 pounds and you kind of swing it around. You can do that in modern cars now, actually. Some of the ones have integrated that thing, and you can tell it to turn on and off the headlights verbally, which is weird. I'm a big proponent of having physical controls for everything. I looked high and low. I even found my old VW car key, the one that flips out like a switchblade. You get to threaten people with. You go, "Who told you? Who told you?" Anyway, this would be funny to incorporate. I could have the whole thing go wook wook when I hit the button. That would actually be very funny. Wook wook. And then do some kind of a 1-2 accessory switch on this. That's a conversation for another day. But again, like, I put this thing in a place that I thought I would be able to find it. I can't. We need to move on. The Switch uses the same schema as we found the stocks of the BMW of that era and the Mercedes of that area. What they do is, instead of having 15 wires coming off of your control is actually swapping resistors in a resistor divider, in a voltage divider. And so what you have is you have your switches that connect to a resistor that connects to ground, and then it switches to a different resistor. And so your voltage levels, boop, 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 represent your 4 positions on your thing. Now, I'm a big fan of taking all of those things and just putting them into a microcontroller and not having multiple voltage levels on a wire. But when you're counting beans and you're like the beaniest of bean counters at corporate headquarters of a major automotive company that will sell the most of any sedans on the planet, you really count those beans. And so when you're really counting those beans, you go, well, copper wire is expensive, so let's minimize that. And that's how they do that. The way they do it now is with a low priority bus, and you pull all the microcontrollers of the devices that are connected. In some cases, you will have wires going out to local things, and you've got local controllers. But these K-bus, the Lin bus, all these buses that they have now, right, where they're all taking public transit, and so all of these cars are integrated with controls. Like this thing, this parking brake from the BMW, modern BMW, it is a digital device. It's got backlights in it. It's got its own controller. Wait a minute. No, it doesn't. Wait, whoa, 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 whoa. I remember now. We took this thing apart. This thing is dumb. This thing does individual pins to the back of this, and it's just buttons that hit buttons on the pins. We could integrate that. This would be fine. Anyway, so that era is really cool because you can actually take the parts apart, take the car parts apart, and you can look at all the stuff that's in them, and see how they, how they pretend to communicate. Portend. But yeah, so I was hoping we could find that switch, because if I'm going to mux it up with these things, we're going to mux it up using the Max 309s that I have an inordinate, like I have so many of them. I don't know if they work at 3 volts, but that would mean I could put an RP2040, which is a much cheaper microcontroller than the Teensy, on this task, and then it would have a muxed set of analogs. And if we get to the point, we will look on the oscilloscope at the settling time of the Max 309. It'll be in the data sheet, but I want to see that settling time on my scope so that I know how long my microcontroller needs to pause after it sets the output, because we have multiple inputs connected to one output, and if we'll use fewer analog pins to look at more analog lines, and that's at the speed of the meat puppet that's operating the device. So the meat puppet is unable to move this lever 600 times a minute. Even your best Twitch teenager streamer cannot, CSGO has nothing on me. I can flip this 10,000 times a second. No, we can flip to those analogs so fast that it's unnoticeable to the end user, especially when these things are kind of heavy. They take a minute to activate. So we're learning a lot about cars and how they're put together and how they do digital communications. And there's a lot of really cool tricks that they use, and everything boils down to, it's just a switch, bro. This is just a switch with a slider. It's just a slider switch that has little rakes on it that go to an exposed pad on a circuit board. And that's it. That's all it is. And then it's got a mechanical coupling so that it does up, down, right, and left. What that translates to in the microcontroller is 4 different voltage levels for 4 different positions, right? And so you have to kind of decode those positions. So hopefully we can get to some programming with this stuff, since we're familiar with all this technology. This is stuff that I've used in synthesizers and I've used in simulator stuff. This is all very approachable things. I need to look in one more place. I got to look in one more place. There's that back corner speaks to me right now. I don't know if it'll be there or not, but I need to look. I need to look. I need to know. We've been looking for this part for an hour. A whole ass hour we've been looking for this part. I'm sorry. I'm sorry, chat. Sorry. I don't know. You can pinpoint where a Canadian is from by the way they say sorry. 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 Okay, my stool is holding on to the mic cable, possibly in a rebellious attempt to keep me from looking in this location. Is it under here? Oh, nasty. I thought I vacuumed under here, but man, it is grody under here. Wow, there's a lot of stuff under here. None of them being my thingy. That's a power supply. What the hell? What is it doing under here? And I've got a bunch of industrial switches too that are going to be going into this thing. One of them being the emergency stop button is probably going to be routed through the emergency stop button gets its own wires. It doesn't communicate with the steering wheel module. It gets its own wires because it's a hard cutoff of power, so that if you are currently being critically injured by the simulator setup, you can smash that stop button, hit like and subscribe, and stop getting crushed by the machine. It's not there. Curses. This is bothering me to like the biggest extent. You cannot find a more frustrated project person than one that has lost an item that they deem important to them. This is the height of frustration with shop stuff, is when you lose something. Because it's like, I'm connected to this shop. I don't know if you guys know what it's like to have a space like this, but you keep it neat-ish, keep it organized-ish to your own standards. And so losing something is a personal indictment of your ability to have a space like this. And it happens all the time, so. Bro, just one more place, bro. I know. That's what it is. That's what happens. Unfathomable. I do not know what happened to this part. And it was something that I like. Like, it was something that I really like. All right, anyway, let's get back to this stuff. So we have reverse engineered these stocks. We know how they work. We know how they talk. We need to put a mux on it so that I have more analogs. I could obviously put a $30 teensy on these outputs, and that would enable me to just use all of the analogs in parallel. One of the cool things about this scheme is that if I get a 1024, which by the way, we're storing our analog ports into an int. So the int measures from 0, well actually the normal Arduino analog read goes from 0 to 1024. That is plenty of resolution for us, right? We don't need more resolution than that. In some parts of the simulator setup, we will get much higher resolution than that. We'll get like 10-bit resolution off of a load cell. We're okay with the lack of resolution because that means we've got numbers that are in the tens, the hundreds, and the thousands, right? But if we get a perfect 1024, that means there's no connection to ground on that pin, and we can have that throw an error. It can say there's no connection here, or something is disconnected. And so that's a nice little extra dog-eared troubleshooting thing, right? My puppy is at the groomer's right now. She's getting her hair done. She has long hair, so she goes to the groomer and they wash her and they dry her quickly. That's actually the price of admission is worth the dog dryer. Them being able to dry the corgi quickly so that she does not get sick is very, very important. With a long-haired corgi. So she's there right now, and it's like lonely in the house. It's like quiet. There's no barking dog. but I think she's getting picked up right now, so she'll be back. She never visits me when I'm streaming anymore. I think she appreciates quiet, which is unfortunate for us. I would like to force my dog to come down here and sit in her special little spot, which is back here behind me. That's her little spot. I actually organized it a little bit. I took the horse blanket back out, but then I kicked it all in there last night, so it looks a little disorganized. But that's her special space, and she only goes there if, one, I am not streaming, and two, there's a bunch of commotion upstairs. So when I'm not streaming, obviously it's quiet in here. So she appreciates her afternoon naps in the quiet, and streaming is anything but quiet. I'm yelling at my furniture right now, so she does not hang out down here when you guys are around, unfortunately, because that would be a huge boon for my stream, because people would see the thumbnail and they go, hey, you cute puppy. Uh-oh, I think she's coming down here. Wait, what's going on? What's going on, Bubby? Hey, Willow, come here. Willow, come. Willow. Willow, come here. Oh, no, never mind. She does not want to come down here. I mean, she probably came down, heard me yelling, and went directly back up, because if you guys probably didn't hear it, but there was a thud down the stairs. But if I sit in this stool, she will just leave. She just leaves. She doesn't want anything to do with me when I'm streaming, because I'm talking a little louder than normal, and I think that scares her a little bit, so she just runs away. Willow could help me find that switch. She would know. She'd be able to smell it. She'd be able to smell out the E46 M3 stalks. I'd say, hey, smell this plastic. Now find me the other piece of it. Where is it? She's a corgi. She's not a bloodhound. She wasn't bred for her sniffing ability. She was bred for her intelligence and her maneuverability in herding. Which is why the best toy in the world for a corgi, I've discovered it. I know what it is now. Not this specifically, but there is something that's kind of like this. It's about this size. It's a little bit larger diameter. And it is a rubber hoop. And the rubber hoop has a little launcher that you can use. You don't really need it for a corgi, but it rolls along the ground. And it gets all this momentum rolling across the ground. So you kind of flick it, and it hits the ground, and it spins along the ground. That triggers something deep in the programming of the corgi. And so Willow will put 150% of her running speed into catching it. And she will put, hey, what's up, Madam? She'll put all of her intelligence into it to get in front of it and then have it bonk her in the face when I throw it for her. But she absolutely adores that toy. It's insane. What activity do we have? Smith Clay with a 7-stream streak. Keeper of Maps. Keeper of Maps, how's it going? Resub for 71 months at tier 1. 6 years. I've had this on auto renew for 6 years. Oopsie. That's not an oopsie. That's an advance. That's great. That's great. That's amazing. Thank you, Keeper of Maps. I appreciate the incredibly long-standing sub. And we had a hype train that was Incredimike giving bits. Chester Willer subbed. All kinds of cool stuff. All right. Anyway, yeah. So let's get down to it. So I've got analogues coming from these things that are basically resistor dividers. What we're going to do is we're going to put a Max 308 or 9 onto it. I know I have them. I have them in a drawer. I've also got them in a breakout board. We look up the data sheet, Max 309. I probably did data sheet. This thing is probably long obsolete. I just happen to have a bunch of them. They are basically switching a bunch of different pins onto a common rail, and they're analog. Do they operate at 3 volts? They can operate 3 volts, but they may need 5 volts to do it, which means we can still power this thing off of USB power. Minimum is -15, maximum is 15 volts. 15 volts, that's crazy. These are really good for like amplifier circuits where you've got plus minus 12 volts going into it. That's how old these are. But I've been using them with digital stuff. I've got one on my keyboard that's behind me. They work pretty well in that sense. Minimum DC voltage difference. Where are we going? On-off leakage, com-off leakage, com-on leakage. What did Bother just say? Power supply range. Minimum is plus minus 5 volts. Yeah, it looks like, so we've got to give this thing 5 volts. What's our pinout? Those timings are something that we might be interested in, but so the 308 does 8 to 1. We want the 309, which is 4 and 4. And I think I have one, and I think it's somewhere in here. We got to look for more stuff. Hooray. It actually might be out. It might be on the top shelf with all those other crazy circuit boards. Whoa! Where are they? I don't see. Okay, let's take a look at the top shelf. I think it's sitting out. It's just right over there. Because we'll hook that up and then we'll use an RP2040 instead of the Teensy. Teensy's expensive. It's obsolete. It's old, and I don't want it in this system. I want relatively newer microcontrollers and possibly faster and less capable, although their speed is not that important. Oh, I took one off of this. I hope I left the 308, or sorry, the 309 behind on this board. Please tell me I left the 309 behind. I froze the camera. God. Stupid. The USB B. Hold on. Deactivate. Unplug it. This like fits loosely too. We really need to fix this one. I need to make it a USB-C so that it clicks in, because that is just so incredibly prone to failure. There it is. How are we looking in terms of whoa, whoa? And so when I do that, that means that I need to restart Stream Deck because it doesn't detect the camera. Quit Stream Deck, quit. And it thinks that it can't adjust it. We're back. We are so back. Welcome to Bother's Technical Difficulties streams. You guys need to tell me right now where you put that switch, because I'm thinking about it. It's on my mind. I've got that switch on my mind. I know you guys did something with it. The new version of Stream Deck keeps popping up, and it's like unable to update, so I need to actually go in and manually update Stream Deck. Very, very annoying. But now that I've done that, I can actually do the procedure on the micro, which is bouncing the settings around, and that fixes all the frame rate issues. Even though things are a little bit wobbly, that sort of fixes it. Okay. Anyway, please tell me I left 309. The switch will haunt this stream. You've got to do something, oh bother. 4-hour search stream for the win. Don't you tempt me. I did leave the right one. Ha ha ha. Ha ha ha. Ha ha ha. Things are finally coming up, bother. That's right. Our luck is taking a turn. Put it all on red. I did leave the Max 309 behind. Good. For some reason, I took the 308, probably because I ran out of them. And I'm not buying more of these. If push comes to shove, if this finally comes to a head and push comes to shove, I will get different Muxes, more capable Muxes. We know what our code's going to look like. I'm going to, of course, base the software off of our previous code. We did it with the most overpowered microcontroller on the planet. It's not true. The really overpowered one is the Teensy 4. The Teensy 4 is some crazy ass 600 megahertz thing. I don't need that. An RP2040 is relatively advanced for what we need to do. So I need to find an RP2040, the Steed Studio. Hi, my name is Steed, and this is my studio. Steed Studio Zhao RP2040 that does not have a radio. I do not want, when I power this thing up, I do not want 500 IP addresses coming out of it, right? Very, very specifically not RF enabled. I do not want it. Take it away from me. You know, I used to have a bunch of RP2040 JAWs here, and this one has a radio on it. I just, theoretically, somewhere in here, there's one of them that doesn't have a radio. Unless it went to other projects, which is a distinct possibility around here. But these things are cute. They're like these cute little things. And if I put all the analogs on one thing, the digitals that we have are just buttons. Potentially could be muxed as well, but I don't think we're going to need that many for the digital. There's like a couple LEDs, maybe a backlight set of LEDs. They're all gone. They're all gone. None of them are here. Where are they? What happened to my microcontrollers? Ah, you are looking for a switch, traveler. I have riddles that you must solve. Is that a gun? Oh my god! All right, let's see here. This one would work, but I'd rather use one that isn't currently plugged into a synthesizer. That one has a radio on it. I'm going to collect them over here so they get back into the project bin. That's another Raspberry Pi that's sitting around. There's a bunch of freaking paper antennas for the RP2040s. Oh, there's the Arduino Uno. Arduino Uno. I have it here just as an example. Put it like over here. If I end up finding the switch just by going through this stuff, I'm gonna be inconsolable. No, it's not under these things. I don't get it. I bought like a bunch of RP2040 JAWs, and I guess they've gone to projects. There must be a couple of them in modules right now. So maybe we will steal the one off of the front of this thing. It's also possible that there's one sitting in the dog collar project bin. More than one. And maybe some other project bins are filled with RP2040s. I don't know. Like, I had a bunch of them. I think I bought like 5. RP2040 missing, BMW, Switch missing. Someone is up to something. I think it's more that I'm just terminally disorganized. Uh-oh, I touched the mic cable. I touched the cable for the microscope. That might be a death sentence. Let's check to see if it's still good. Okay, it's still good. We're still good. We're still good. All right, so the only RP2040 that I have in reach is the one that's currently on the synthesizer, so I guess this one gets sacrificed. And I don't know, maybe it's not that bad of a thing if I put a radio, one of these, on a synthesizer. So your synthesizer activates a bunch of IPs when you turn it on, but then you can remotely go into it and reprogram it. So maybe that's not such a bad idea. Now this has these crazy circular pins, so it's not really going to stick in the breadboard very well. These are really good in circuit, like if you're building a breadboard circuit. These are really good. They make a very nice, strong connection. They hold your shit together, so if you drop it, it doesn't fall apart. They're low profile. They don't stick up all that much. You could still hide stuff under them, but they're kind of tough to plug in and out, but they make a great connection. They're a little bit more expensive than square headers. They're really good, except when you use them in a breadboard, they barely make a connection. That'll stay in, but if I bump up against it or something, it can just easily pop out again. So we'll put that there. That'll be reprogrammed later on. Yeah, it's serviceable, but it's not amazing. All right, so we're going to be hooking up all this hardware and then programming it with the easy peasy software. It's not going to be anything complicated. And maybe eventually this will lead to the CAN bus thing. This board is going to be kind of weird to operate on this. Maybe I will do jumpers and then we can hook it up to the rest of the CAN devices. But this will connect to all of our analog stuffs. So we've got to figure out what our circuit's going to look like. because we've only got so many outputs on this thing. But all we need is the input pull-up functionality from this, and the analogs will come in through that. So it'll be 0 to 3.3 volts. And I guess our analog hopefully is tuned to that. We'll figure out what the variables are when we get there. Our circuit is going to be relatively simple. I can draw it right now. It's just going to be, oh wow, we have a lot of, I'm going to close a couple Arduino things here with the CAN testers. There we go. Okay. So let's see. We want the PDF, which is not, what? Where's the, did I close the whole Firefox window? I guess I did. All right, let me Control-Shift-T, get all that back. There we go. I hit the wrong box, and I guess I closed all this stuff, all our research material. How big on screen should it be? About that big. And then snip. Now I could incorporate like a screen with the RP2040, and it could, well, we still need to have the one digital bus there, so all right. So I mean, you know what, I don't really need to totally suss out all of the exact connections. I mean, these COM A and COM B are just going to go to the subsequent like A0 and A1, right? Let's get the pin out of the RP2040. Or no, that guy. We get maybe this one. The direct linking to images that Google stopped doing is possibly the height of my annoyance with the internet. Open image in new tab. That's too big. I guess I can resize it. Hold Control. Nope. Shift. Control. Alt. Shift. No, never mind. Trying to keep it from distorting when I do this, but I guess it's just going to get squished. Oh, that looks terrible. So A0 and A1 are D0 and D1. It's on that side. We've only got 4 analogs in your small microcontrollers, or at least the ones that I interact with only seem to have 4 analogs. The Teensy has like a billion, but... Are those not working? What happened? Maybe I just don't remember, or maybe chat's just been stale. No, chat's just been stale. Chat's just been stale. I just looked up and I saw a fart redeem, and I'm like, I don't remember the last one that I heard. So A0 and A1 are our control pins. Those will be going towards digital. I'll probably put them at D4 and D5, although that's SDA and SCL. So maybe not 4 and 5, because we're going to need SDA and SDL. We're going to need those pins for communication with the CAN bus stuff, which actually it's MISO and MOSI that we're going to need. MISO, MOSI, serial clock, chip select. So that's this side is taken up. We've only got 1, 2, 3, 4, like 5 pins for the buttons, which in this case we've got 1, 2, 3, and then the key is going to be like 4 and 5. But there's also buttons on that switch complex, so maybe the Zhao isn't the answer to this thing. Maybe we have to go with the Pico Pi. That seems plausible. The Zhao would work on something that has less I/O. Oh, I just found another Zhao. I just looked in the bin and actually found another one that isn't already slated for the synthesizer. It's sitting at the bottom of this one. But let's get the Zhaos away. We're going to use Pico Pis. What happened? Gave you guys a head injury. This part of the process is it's never smooth. It's never smooth. Choosing the right microcontroller for the job, and the selection that I have is a little bit limited. I mean, it's possible that I could just use the Pro Minis to do this, but the Pro Mini is very much obsolete at this point. Where'd those other two go? Oh, here they are. And then we'll take one of these. Do I have any with pins on it? Didn't we have one with pins on it that... I think that went to a different thing. All right, so we got to do some desoldering then. That's fine. It's Friday. We can do physical stuff for a little bit. And then, oh, wait a minute. No, the one that I had... Shit. This one goes back onto the synthesizer. Where'd it go? There it is. Luckily, it's the only one with this type of header on it. I was hoping the Zhao would work in this instance, but we just don't have the amount of digital pins. And the RP2040 has 4 analogs and like 1 million digital pins. So we have all kinds of all kinds of headroom on this. Up head, head up, head on, apply directly to the forehead. I never knew where I should put head on. It's so complicated. All right, so this goes away. This goes back up here. Where did it go? It's just every time I get a spare fleeting thought, it seems to be dedicated towards the location of that switch panel. I'm so cooked. I'm vexed. I'm just thinking about like what bin it possibly could have been going to. All right, so we got to desolder this whole thing. This, I think, fits in the vise, so this will be an easy desoldering job. We'll just use the microscope to do that. I'm going to move this stuff out of the way so I have a little bit more desk space. Too much flammable plastic sitting on the desk. Typical, oh bother, putting all of his flammable desk stuff on his desk. Stuff. Streamer, I believe you have flammable items on the desk. Get the brake pedal out of here. This thing, I don't know if this will get its own, like, bus computer, or if there will be, like, probably better if there's a pedal computer, a pedal microcontroller. Because, like, the newer ones are direct to CAN bus. All right. BMW teleported it back home. It fell through the map? Oh no, it's going to be at the junkyard. Surprisingly, the junkyard in my summer car is not a pay junkyard. You don't pay anyone. This thing is rusting a lot more. I haven't used it in a little while. I'm going to lose grip on this thing as I remove the solder from the Amogus. Did he just say Amogus? Why did he say Amogus? Because it's covered in Amogus. All right, so let's do a little sucking. Yeah, I'm like clamping to solder here, so I don't know what happens when I desolder. Oh, I guess I can use this. This tip is a little bit much for these pads, but I don't think it'll harm it. And we're using the Engineer SO2. Actually, SO3, this is the updated version. Solder Sucker, made in Japan. It uses the Star Trek TNG font, and it has a silicon rubber tip that you can replace. And that is really important because that means that when this thing gets clogged, you can pull this thing apart, you can replace the O-rings here, and there's a couple O-rings back here, and you can clean the spring off from all of the solder, and you can continue to use this as if it were new, which is probably bad news if you're selling the product and, you know, 4 people buy the product and then they never have to buy it again. But it's awesome for us because we can refurbish this thing fully. I need that to be a little taller on the vise. I need to like machine a little shelf on this vise so that when I put circuit boards in here, I can grip it and then have it sticking slightly over the top. Although this is a pretty thin circuit board. Maybe we'll just float it over the edge and I'll readjust. What's up, Wayne Johnson? All right, let's see if we can get some suck going on here. Oh, maybe I have to use braid on this. I don't have a lot of control with this tip, too. There we go. So I want them all to just look like that. This is way cheaper than solder braid. Solder braid does a really good job, but where you can, using the suck is a lot better. And also you get really beefy thumb muscles from this because I'm resetting it with one hand. When you're reworking solder like this, it's good to have the big tip because that's got all of the heat inertia as well as being able to add a lot of heat to the circuit and get it to become molten all the way through as quickly as possible so that you can get that solder out of there without damaging anything around it. But all of that heat, all that noise that you're bringing to the table can also damage the board because it is just FR4. It's just fiberglass with copper deposited on the top of it. The amount of sticking that that copper does can be limited and it can be harmed. This is running into the problem with the solder sucker that I ran into before, which is where it will not be able to advance that little poker because it's clogged. So if I use a pin tool on it, the previous version of this did not have such a sticky material as the plunger. I don't know what they changed. Yeah, it's stuck. So before I bend it, I'm going to open this up. This thing's going to spring. It's going to launch at 1,000 miles an hour. Oh, there we go. Take a look at that. Did it break off? Wait a minute. Huh. That looks okay. Nothing stuck to that. There's just something in the tube there. Try poking it from the other side. There we go. That was our culprit. That little bastard right there. Solid slug of solder. But again, this thing allows you to do that. Take it all apart and make sure that your holes are clean. Oh, I should probably unpress the plunger to put this back together. There we go. Yeah, I'm gonna be up like to the wee hours of the night looking for that stupid switch. I don't know where it went. I can't seem to fathom where it possibly could have ended up. And then it gets stuck again? Are you kidding me? Now, that won't let me reset it, but still, there's something about it is like sticking the solder in there. What I'm doing is I'm prepping this thing for getting a header so that we can plug it into the breadboard. The solderless breadboard. Why do they call it breadboard? We explained that last stream. Yesterday, in fact, we were talking and somebody said, is it because it tastes like bread? No, lead is actually very sweet. I've never tasted lead directly just because, well, okay, as an adult, as an adult, I've never tasted lead directly. As a kid, there was a windowsill in our old Philadelphia household that had paint dust on it, and the paint was leaded. And so at one point, my folks were in New Hampshire, my grandparents lived there, and I was at home in Philly, and blood tests came back saying that I had elevated lead levels, and I almost got taken by Child Protective Services because my folks were not there. It's lead salts that taste sweet. I see. Well, anyway, point is it is it a breadboard because it tastes like bread? No, it's a breadboard because back in the day with old school electronics, you know, the era where you've got the big knife switch and, you know, you cackle and it lets out a huge spark. That era, all of the electronics were basically not panel mount, but they were like they would mount to a board which did not conduct electricity. So like your resistor terminals would be on top of this whole thing that you screw down to a board. And so the most common boards to find around were wooden cutting boards, breadboards. And so that's where the term comes from. Look at your desk. Can you ballpark what everything on the desk tastes like? Everything but the solder, yes. And flux. Flux would probably taste like nasty chemicals, so maybe that would be okay. I thought that was a more well-known fact, but apparently it's not. But yeah, like, you know, like your, what is it, light bulb holders and stuff like that, those would all just go on a board. And so the best non-conducting board is a board for cutting bread. But yeah, I like how Bother's talking about random stuff, which includes stuff that he went over with last stream, and he somehow has rolled that into the time he almost got repossessed by Child Protective Services. Needs a bigger tip. The big tip is important when you're doing solder rework. I'm hiccuping a lot. Sorry, I had a hoagie for lunch. Okay, you had to know. But anyway, so the big tip is really important. I mean, in general, big tip is really important to use when reworking solder, because when you put it on to like a ground pin, and the ground pin wants to dissipate all that heat to all the ground, it doesn't want to do that. It does that. Basically, what happens is the big tip will heat it up very quickly, and so you can get molten solder through the entire pin, even if it's a ground pin with the giant tip. Quickly, because if you hold high heat on the pin too long, it is just deposited on top of the fiberglass. It will come off with an overheat. I know I do need to get a haircut. It's a little mullety in the back. I've been too ADHD lately, and I just need to schedule it and get it done. And then I'll have short hair. But some people like the long hair bother. None of those people are anywhere close to oh bother right now, but they do like it. So I do have some proponents of the long hair, usually in chat. This one is not cooperating, and I don't have a hole through it, so I need to add just a little bit of solder to it. This is unfortunately going to take us a little bit. This is just part of the thing. I can't ask ChatGPT to do my soldering for me, so it just takes us a minute to get the microcontroller set for breadboarding. I should probably already have a couple of these set for breadboarding. The RP2040 is a nice, cheap $5 microcontroller that's extremely capable for what it is. Wayne Johnson likes it. See, that's all I need. That's all I need. Plus, I have beautiful hair. Absolutely gorgeous. So, you know, oh wow, look at what I did. That's just gonna break off of the... So apparently on Raspberry Pi 2s, they used such cheap power circuits. And I don't know if I would call that cheap. They actually look very technological. Did you see the wet brush for removing solder the other day? No, I did not. Somebody posted in my Discord that apparently with the Raspberry Pi 2, the power supply that they use is just an exposed piece of silicon with a bunch of pads underneath. They say it's for, it's cheap. I think it looks extremely technological. But what it means is that if you set off a flash bulb nearby, and it gets into the chip, it will reset the Raspberry Pi. I gotta be careful that I don't desolder any of this stuff. Getting that one back on would be a nightmare. But yeah, you can set a flash bulb off nearby and restart. You know what, I'm gonna flip this over. I'm too scared of grabbing onto any of those electronics with this giant soldering iron. The reason behind that is because silicon is very directly tied. Transistors are basically diodes, and they're directly tied to the infrared spectrum. They let out little bits of infrared light when they actually switch. So if you take a laser beam, if you're Scandinavian, and you take a laser beam and bounce it off a certain part of the PIC microcontroller, you can reset the lock bit. It's just a single bit that says whether or not the microcontroller is locked. You can reset that lock bit with a laser, and then you can extract a hex file of the programming of the microcontroller. That kind of security research is crazy. I found a paper about that once. So the same thing with the RP, is not RP, same thing with Raspberry Pi 2, is that if you set off a flash bulb nearby, take a picture of it, and that power supply is exposed, if you haven't put something like blue tack over it to cover it, it will potentially restart your Raspberry Pi. It's crazy. That's Raspberry Pi 2. Someone using a little wet paintbrush to wipe off hot solder. It looked really effective. I guess maybe what it does is the steam expands and then it pushes it away. Having like all of these pins as wet solder, I don't think that's going to be great for me here. You could also read out a running chip with a high resolution infrared microscope. That's what they did with the Omnipod, the old Omnipods, not the ones that I use. The old Omnipods, they took a picture of a bunch of the Omnipods, and it was an electron microscope picture of the programmable memory of the microcontroller, and then they used MATLAB to determine by physical appearance whether or not a 1 or a 0 had been set for that memory space. Yeah, it's the same as cleaning your iron with a wet sponge. I guess you're just moving it over to the controller. I mean, like, I suppose that could work in this instance and make it a lot faster, but I feel like if I'm dealing with that level of heating, I'm still risking my biscuit with all the other components. I guess if you heat them all up at the same time and brush it with a wet brush, but you could also do it individually, right? And that could potentially save us time, although you can see how quickly this is going. I am revealing all of the analogues. Do you guys remember? Do you remember Among Us? I forgot to say hi to Disco House Days. Disco Sunday. Sorry, Disco Sundays. It's no longer House Days. It's a different account. Keep getting banned. That would be the Australian shitposting genes in that part of my family. I don't have them. I don't have them. I'm more New Jersey than anything else. Disco Fridays. That'll be the next account after this one's banned for reasons that they will not divulge. It's like 4 o'clock in the morning over there, so generally when I do see my cousin in chat, cousin in chat, all this family tree stuff, I'm like, why are you here? Why are you not in bed? And then he goes, "Oi, matey, how's it going? Oh, yeah." He doesn't talk like that. I don't think. Does he code switch? He might code switch when he's over there. I wonder if he code switches, and it's like really embarrassing. That would be hilarious. Find a video of him talking nowadays. We have lived in opposite sides of the East Coast. Not really totally opposite. The opposite sides of New England. So I have not seen him a whole lot. But right now he's overseas. I like working on my very embarrassing accents. I'm not trying to like reproduce an Australian accent. I'm trying to reproduce an embarrassing Australian accent. Without saying crikey and all the Australianisms too much, because it's funnier if you just do it without stereotyping. Although it is stereotyping. And then there's the constant debate about whether or not doing an accent is racist. And it can be. It's actually very easy for it to be racist. You have to be careful with your humor when you do an accent. When I do an accent, I do an embarrassing accent in a way that's not supposed to be racially motivated. But I don't do like a bad Chinese accent, you know? And if I'm, for instance, like with friends of mine who are from India, on my design team, there's one of them who would always promise too much, and he'd be like a used car salesman with his assignments. He'd be like, "Oh yes, of course I'll get that done for you." And I was joking about it with the rest of the my friends and teammates there, and they were like, "Hey man, that's racist." And I'm like, "I'm not making fun of his accent. I'm just making fun. Well, but is it like, maybe it is. I don't know. You got to be real careful. If I had cracked this in the right place, I would have had the 2 rows perfectly. I wonder if they planned the amount of output pins around that, because it was a whole damn header and I cracked it 1 pin to the side. And so now neither of these fit, although one of them could fit, and then I'd have an overrun of 1. The best tool for cutting these, by the way, is the wire cutters, the wire strippers, because the wire strippers have a blade on them that is like so. You have a taper on both sides, whereas the flush cutters have a taper only on one side to the blade. And so these are really good at cutting things flush, but if you want to cut something even, it helps to have the blade hit it more towards the center. I solved the problem by not being able to do accents. Yeah, that's, I guess, another way to go about it. Just I straight up just can't do them. I can't do them on camera. They just don't sound right on camera because I'm second guessing myself. That's the difference between a theater kid and a stage crew kid. Over 1. Don't get it wrong. Don't fuck it up. Still off by 1. Can you, I'm on camera, right? Yeah, okay. Right there. There we go. That's the proper spot. And that splits it exactly in half. So now I have 2 things, two headers that are the right lengths. If you get it wrong, you already have the other half. If I get it wrong by 1, if I get it wrong by 2, which I almost did, then it's all bets are off. All right, we've got Asmer soldering to do. A couple of these were not quite as open as I would like them to be, but I think maybe we can just smash them down on top of them. Yeah, it's because everybody's watching. Everybody turns around. I'll do a perfect fake accent of something. But you all have to turn around. Nobody's allowed to peek. Yeah, this will fit on. Okay. Let's see how this side's a little bit more accommodating. See, I didn't do a whole lot of rework on this. If I really wanted it to fit perfectly without any sort of slightly too narrow holes, I would use the solder braid on it. I quit the wake-up call working on an alarm project late last night. It goes up to 9999, so I calculated 16 plus minutes. Turns out I divided wrong. I let the counter continue. The screen went dark. I fell asleep. Watching you in my chair, I woke up 166 minutes later. This is Kavorka Designs. The siren bearing, not knowing where the sound was coming from. I turned the TV off, the stereo off a dozen times before realizing it was the alarm buzz. So now you know, Kavorka Designs, now you know what it is like when an insulin pump runs out of insulin in the middle of the night. Because by the unfathomable and perfect design philosophy of, is it tandem diabetes? No, that's not tandem. That's whoever makes the Omnipod. They decided that when insulin ran out, so too shall your patience. And when you run out of insulin, the pod, which is located somewhere on your body, because it is an adhesive patch that is able to inject you with a little tiny blue tube, and then all the insulin in the reservoir. So the reservoir fills with insulin. You put this little unassuming little troglodyte somewhere on your body, and then it smashes you with a needle and leaves behind this thing. So this could be located anywhere. I've been using my arms lately, so my arms look absolutely, it looks like I got into a fucking fight. If I take my shirt off, it looks terrible. I have like bruises and red marks. It's the cost of doing business. But anyway, so this is on your body somewhere, and what it does is it decides I'm going to activate my beeper. Beep, and it does not stop until it runs out of batteries. And because I'm using these for microbolusing, supposedly the batteries are pretty low. It seems like the microbolusing uses up a lot of the power of the microcontroller. I'm fine with that because this thing lasts the 2-ish days that the insulin lasts me. It's been a little less because I've backed off of some other meds, but anyway, as I lose weight, these will last longer. But when these run out of battery in the middle of the night, or run out of insulin in the middle of the night, it beeps. And so you wake up to this constant alarm beep if you don't happen to be rolled over onto it. If I'm rolled over onto it, it actually, because the buzzer you can see right there, it's that light colored circle, it uses the outer shell to help it beep. So when you roll over, that quiets it down. But the confusion from being woken up by a constant alarm is a real thing. It's something that I had to deal with last night. We were living the same lie. Wait, did that fart come through? I don't remember. That's why you make your alarms unique. I mean, look, the smoke alarm in here does have unique alarms for different things going on. And I can tell you, when you make your alarms unique, that means you have to also have a very good manual. Because we had absolutely no idea what was going on. I did it. It was very inappropriately timed. Oh, good. That's what they're there for. Kind of like the highest honor of this channel is to break Burn the Subs somehow. And we had people breaking Burn the Subs, not just through profane screen names. They were breaking it by getting multiple subs. And so we were able to come up with a couple methods to keep them from that. I'm going to have to figure out what that looks like coming from the Twitch API and see if they've done anything at all to help us not have repeats. Because we're now using a different system for getting to the Twitch API. It's a more centralized system so that if my Twitch interactive things break, I don't have to look at 500 different devices to see what broke. But then at the same time, I don't have all of those specialty rules behind names going into the database. We can store certain things, and maybe those will contain our checks for whether or not somebody is gaming the system. Because somehow, you know, like you can declare your sub, close the page, come back, and declare it again sometimes. What's up, Flask? With channel point redeems, they give you an alphanumerical identifier of the channel point redeem. Channel points are more secure than subs, and subs are the ones where money changes hands. I think bits might have the alphanumeric ID too. That ID I could have just saved with the sub, and we could check against it for any subsequent one. They have not implemented it into the subs stuff, which is baffling to me. It's just baffling. This is why I don't like Flux, because it's dust is sticking to it. Right now, we are just soldering Amogus. That's all we're doing. I'm getting this microcontroller breadboard ready. This is how you do it. So that we can build up our little stock computer. And it's going to use this microcontroller. We'll transfer it eventually to a perforated prototyping board where there will be a bunch of plugs for the various accessories. And then this thing will speak in CAN bus to the rest of our system. But for now, we're going to be using serial prints and just seeing what we can get going. Now, this thing only has 4 analog pins. Of all these pins that I'm soldering, only 4 of them are analog. But all of the rest of these are general purpose I/O and like SPI pins and stuff. So we'll be able to, if we want, attach a screen to this. We'll be able to attach the CAN bus controller to this, and the RP2040 is fast enough that it will be able to, you know, fathom all that stuff. We will also be able to connect all the buttons, and that's why we're using this now. Is we're going to be using a Mux, and then all the buttons will be connected directly to the microcontroller. And the Mux allows us to ping all of those analog inputs and put them on fewer analog inputs. We can get 8 analog inputs on 2 analog pins, or I could do 8 to 1 if I want to use the other one. We don't really need to do that, and that would probably slow down our polling of the analog pins, because the Max 309 is not the fastest in the world. I do have it running on my keyboard. It is actually working on my keyboard just fine. So I don't think, although I'm not, you know, I'm not like a CSGO player. I'm not a Twitch gamer. I'm a Twitch maker. I'm broadcasting on Twitch right now. No, I mean, Twitch gaming is in like the fast movements and stuff. I don't play that kind of game. But when I am typing very fast, I don't feel it. It doesn't feel like there's any kind of a mux, like an analog mux working on the thing. So theoretically, this could be fast enough for human inputs. There are more modern muxes that work much faster, though. All right, so the RP 2040 is a 3-volt compatible device. The Max 309 is analog. It works up to and below 15 volts. Its minimum voltage is 5. So we need to get raw power from USB onto the rail into the Max, and then we will use 3 volts for input pull-ups. Let's check about the input pull-ups on these things. So, Picopi, pin out. Picopi, PP, I'm a Pokemon. Remember that? Do you remember Pokemon? Okay, let's take a look here. Power, ground, UART, GPIO, ADC, SPI, I2C, system control debugging, and then something I can't read. I can't see that. That's a bad color choice. So there's no word about whether or not input pull-up works on every pin. It might. This is not the right one. This is the wireless one, isn't it? And then V-bus is going to be our 5 volts. Because we need to give the Max 309 5 volts and ground. Our devices only need ground, and then we'll use the input pull-ups to sense the analog levels. Okay, well, where is that pinout? I'm just going to grab a better looking pinout. That one's terrible. That one's a little better. Is that the right one, though? Oh, no. Ours is this one. Ah, I hate the clear background ones. Okay, the text gets larger, but the image doesn't. Really? No, that's not a good one. There's got to be a better one. There's got to be a better one. Let's take a look here. What do we have? Oh my God, I can't even see that. Ah! Try again. Can't connect to circuit state. There's so many nefarious web pages on these when looking for things like a pinout. Everybody's using the same image, aren't they? That one is just hard on the eyes. I do not like that. This one's kind of even worse. I kind of want to use it though. Copy, put that in here. So basically what I'm going to do is I'm going to be hooking up the mux to 2 of these analog pins, and we're probably just going to use the first. This is a really hard to look at image. ADC 0 and 1, so it's going to be GP 26 and 27. Let's go to this view, and then I'm going to get a new jumper wire kit just so that I'm not pulling my hair out looking for certain jumpers. And then we are going to get to work on this thing. So go here. Is that far enough away? It's still a little claustrophobic for what we're doing, but I guess it'll be okay. So over at the top right corner, we have V-bus, V-sys, and ground. V-bus, V-sys, and ground. I'm probably going to need tweezers. Where did those go? Where now could my tweezers have gone? They're probably out on the desk somewhere. They usually are. They're not on the desk somewhere. I don't see them. If I don't see them, they don't exist. Simple as that. Oh, here they are. Found them. Okay, so I need V bus to go to plus, because we're going to send it up here. And then ground here is just going to go to the minus pin. V bus to plus. I guess I could do it with this. Is that going to be a little weird? It's going to be a lot, like all kinds of weird. And then we are powering our LED with 3v3, so it's going to be kind of weak. But we do have, I put a 220 ohm resistor on it, and it was a good brightness, so I guess they designed their optics with that in mind. What? Ground is here, so I have to go. It's going to look stupid. I hate it. And then these are always flared out way too far. I don't know why they can't just pinch them in for us. Oops, I did it the opposite way that it should be. It should be like that. Come on. There we go. Okay. Oh, that sucks. That's terrible. Here, do this. Sneak that in there. Oh, I hear barking. Yeah, so that was Willow that came down to visit. She almost came in to visit, but she heard me yelling at the furniture. Oh, wait a minute. That's the wrong pin. This is the one we want. Yeah, it's always the dog going, roar, and then motion detected at the front door. I bought the Amazon lady before the dog. Should have just gone with the dog, because the dog is a better early warning system. Willow's been super cute lately. She was being super sweet last night. She was like falling asleep, sitting with me. It was very, very cute. She normally is not like that. She's like that with visitors. She flirts with visitors. If somebody comes over, especially if they're a tall guy with a beard. I think I know Willow's type, but if they're a tall guy with a beard, she will be the sweetest animal in the world to that person. It's disgusting because she doesn't sit with us on the couch. She gets off the couch immediately. You put her on the couch next to somebody and she goes, next to us, and she goes, no, it's okay, I don't want to be here. And she just leaves, right? But when you have a guest, she'll jump up on the couch and she'll go, hey, how's it going? What you thinking about? I'm like, oh, it's disgusting. It's disgusting. Getting the connection to the analogues to be short is going to be nigh on impossible because they connect over here. If I flip this thing around, then I've got all this space over here that we're not using. And I could cut this board right here. I could cut it, but I don't know, someday maybe I'll put the Max 308 back. Maybe not. I don't know. I should probably cut. I'm too lazy. So what do? A0 and A1 are up here. Then you've got enable as pin 2. That's enable. Then you have V minus. And on the opposite side, you have V plus. Oh, what an annoying way to do that. V minus is here. I just put 5 volts on this line, not on the other one. New smells, very exciting. Maybe. I don't think it's purely a smell thing, though. Because she, like, looks into their eyes and is like the sweetest dog in the world. I'm trying to think about how I can cut this. I guess I can't. We're just going to have to live with it being a little weird. This is a Mux setup test. I put this together specifically for the keyboard projects, but yeah. So A0 and A1 are on this side, which means this goes over to here. Let's hook up power first. Power first. We power our chip and then we can hook up all the rest of it. Whether it be through big wobbly wires or little wobbly wires. And then minus, we'll get a ground from the other side. There's a lot of grounds on the RP2040. There's a lot of pins coming out for this thing, and every like 4, there's a ground. Which is just tied to the very large ground plane on the top layer and bottom layer of the board. So all we need to do is get a yumper and get the first yumping ground, which is the second pin right here. That's nice and easy. And now that rail is connected to ground, and we can properly connect our Max 309, which is way over here because we've got this big dead space. That's going to make this breadboard setup a little bit annoying. Hopefully I don't need to do much. I mean, I'm trying to work kind of quickly here, but I always go to a certain standard. So pin 3 is V minus, which is ground. Doot, 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 right there. Cool. Very cool. Love that. Love that for it. I hate it when they do this. And this is my fault because I've got all these dead pins over here. I don't know why they put the gap. Hate it. Okay, let's see. Another one of these yumpies. And we're going to V plus. So we're I need a slightly larger yumper. The black jumpers are the ones that go very quickly in these kits just because they are the exact right number of spaces to get from the power rail to the thingy wingy. 3 down right here, middle of it again, super awesome. There we go. Okay, so that's this thing hooked up to power. The enable pin, there's no line over the enable pin, but I'm not sure if I trust that. I'm going to look in the data sheet to see how the enable pin is realized, how they use it. How do you use the enable pin here? How would you say you are enabled? Okay, and then A1, A0, enable. There's a table. The enable table. For the label. Do, 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 do. On switch enable 0, 1, 1, 1, 1. Okay, so we want enable to be on. On can be 3 volts, it can be 5 volts. In this case, it's going to be 5 volts. A0 and A1, what are their thresholds? What are their thresholds? Can I enable them with 3 volts? Transition time. 80 to 175 or 250 nanoseconds. That's Tmin to Tmax. TA plus 25 degrees. Okay, so nanoseconds, huh? We're still going to have to put like maybe like a 1 millisecond delay on it. Input current with input voltage low. V enable 0 or 2.4. VA 0 volts. So I think the threshold is below 3V3. But can it be? Can it be? I think it can be 5 volts. That's positive supply. Crosstalk. COM off capacitance. Oh, somewhere around here the specs will be. I'd rather get them experimentally. But I think maybe if we just hook this up to 3 volt logic, it'll be okay. The enable will be getting 5 volts, but then the channels themselves are going to be operating at 3. This is the thing. This is the thing that you have to stress about when you're building circuits like this, and especially given the vintage nature of some of the electronics that I have around here, you just have to make sure that your supplies are going to be okay and that you don't blow up your project with using your project. Pin 2 is enable. And it's on this side of the board. God damn it. God damn it. I'm going to send that to the positive rail. We're going to have a 5 volt rail on this thing, which is weird. So that's enable. Come on. These tweezers were not meant for these wires, and this one's a little too long. Still, whatever. Now we've enabled the chip, so it's always active. And I've got to do a jumper back here from positive to positive. So I'll just get an orange wire and do this. So I'm just gonna, here, let's get a little closer like that. Plus, this is like arm cam. Go down, over, up, and then back down like that. And now I just have this little orange jumper going from positive rail to positive rail. Negative, I don't need to jumper because it's jumpered through this thing on this circuit. Okay, power, ground, 5-volt enable. Now we need our digital pins. So I gotta go back to my notes. A0 and A1. I could do as 14 and 15, but then I would have to, yay Raspberry without Wi-Fi. I prefer not to have everything on Wi-Fi. I don't know why that's been such a thing that people have stressed with modern technology. While it's convenient to be able to go to the IP address and upload code, I don't really appreciate having all those IP addresses, you know? Not everything needs to be wireless. So I was thinking like I could just do 19 and 20 for A0 and A1. I guess sneaking around to the other side is easy because we're on this side. So if I do A0 and A1 there, and then this is going to be, I don't know which one's going to be COM A and COM B. Coma and comb. Where's my comb connecting? I guess we'll just do them in order. COM A. And then COM B. Wi-Fi based smart home is disgusting. I do use some smart home things to power this stream. I should come clean about that. The lights turning on and off and all that stuff is all automated through Node-RED. And Node-RED is also controlling Twitch interactivity as well. I won't lie to you. I am using that technology. For good? No. For stream. So A1 is pin 16, which is this one up here. This is going to be a little long for that. Maybe a red one? Red's longer. I could always cut it to length too, but I don't want to do a lot of that. A0, okay, so I want to go out here like that, and then we'll pull a left-hand turn at the analogues. You guys can't see through my arm. Yeah, what I really need to do, and the smart thing for me to have done at the beginning, was to get a different router, get a separate router for all of the Internet of Things things. I didn't know I'd have that many. Here. And then get some of these. Did I make it, or did I mess it up? Hold on. Nope, perfect. Yeah, cutting these to length is a better strategy sometimes. So there's A0, and then A1 is the next one down, and that one goes a much shorter distance, which could cause a little weirdness in the settling times of the two. And actually, it's okay if I block a whole bunch of these, because none of that stuff is used. Maybe a little longer than that, although there's no sizings in between those two. There's a lot of like mid-sized wire lengths that are just missing from these kits. That was way too, no. Where are my analog connections? Or sorry, those are my digital connections to the switches. Can you use the light cables that look like spaghetti as standard wire? That would be cool. The ones over here, those wire wrapping ones, are used in a different system of prototyping that doesn't use solder. It's kind of like this. It's called wire wrapping. So when you with the breadboard, it's good to have big meaty wires because then the little clips have something to pinch. I need to moisturize. That's what I need to do. I've been working on cars today and stuff. Anyway, you have the little pinchy connections and the edges of these breadboard. It looks like that. So you want a big meaty wire because that way you've got better spring contact on that thing. But if you do the other method of prototyping, what you actually do is you wrap the wire around a post. So the specialty hardware that you need is a bunch of headers that have these long pins sticking out of them. Then when you put together your circuit, you are wiring it basically point to point, and you can have like 50 layers of wires that are stacked on top of each other. They used to have those in radios in Vietnam because it was a very compact. Oh wait, V minus is also ground. Pin 15 is ground. This one is ground. Okay, so we got to run this to there. Radio electronics in Vietnam used wire wrapping, and you could actually repair it in the field because it was a wire wrap circuit. It was this big physical circuit. So you would only need that little wire wrap tool while getting fucking shot at. All right, and then we just have common A and common B all the way out here. Those need to run all the way back to, they need to run back to these two pins. Actually, GP26. Now, these pins are numbered on the other side of the board, which is kind of annoying. But we need to go like all the way to here, which probably means orange cables. This one being the least easy to route. I guess I'll come up along here and then go alongside whatever. The other part about these breadboards is that these aren't broken in. I didn't go through and use the pin tool on every single connection, but it's something that I probably should do because otherwise you run into the problem where it doesn't actually accept your wire and it just bends it right off the bat. It's a very annoying problem to run into. So this one's probably, I don't know if that's too far. Okay, which pins are they again? From the top, okay, they give you a little index. There's pin 39, pin 40. And we're looking for pins 27, 38, 37, 36, 35, 34, 33, 32, 31, 30, 29, 28, 27. That doesn't look like pin 27. Pin 27 should be even with this thing. I think that 39 might be, but this should be 40 pins. Wait. 1, 5, 10, 15, 20. It is 40 pins for the whole thing. So pin 20, did they move the processor on this thing? No, that looks like the same thing. So if it's 40, 39, 38, oh, it's not, okay, 16, 17 ground. Okay, 16, 17 ground. Yeah, so, okay. 16, 17 ground. 18, 19. 20, 21. Ground, sorry. 22. Run. 26, 27. Yeah, so we are at the top of the micro. Top of the micro to you. And just to be polite, cross like this. Cross like this. across like this. And then down like this. Cut to length. And strip. And forget how I bent it. That is going to be a long distance for this analog signal to travel. I mean, keep in mind it's already traveled through all of the other wiring harness too. I don't know why my gaming computer behind me is like fanning up and fanning down. It's doing its little fan dance. It's one of the things that Gonad is like trying to sell me on for moving all my computers into the other room, is that you don't have to listen to that fan ramping up and down constantly. Jacksepticeye? That guy's eye was so infected. Why did he choose Septic Eye as his, was that part of, is that like his real name? It just seems like a medical problem at a certain point. Constantly with this eye, with sepsis or whatever. I never watched any Jacksepticeye. I know it's his YouTube channel name. It's not like connected to his real name or anything. Look at how neat and organized I am. People send me these circuits where people are breadboarding and they're making it so super organized. This is about the max level of organization you can achieve in a breadboard setup. Yeah, I alongside the likes of Markiplier and all those old school names. Gotten his likeness in that speedrunning game, I think. Of course, that one just had a whole bunch of YouTubers in it. But you will move it from the breadboard? Yeah, it's not gonna, the breadboard's not permanent. What the heck happened here? Oh, that's just an offcut. Okay, so we've got that all hooked up, and we've got our digital lines hooked up. Now we get to start plugging in our hardware stuff and labeling it on the image so that we can program it. So we can start with the wheel controls. I need to like 3D print something to hold all these together. We can do this on this one. Yeah, so I think our Mux is ready to go. We have the enable connected, we have V+, V-, and ground. We have A1 and A0 connected. We have common A and common B running to our 2 analog pins. If we have a ton more hardware going into this that does this same kind of scheme where you share a wire by doing a different voltage level, we can connect that. We can do that. We can do that. We can do that. So, okay, let me get my jumpers. See, this is what we were supposed to be doing all day today instead of looking for that stupid switch thing. Max 309, it sounds like an oldie. 5-volt logic days. It is an analog mux that replicates how a switch switches the... No, wait, that's the other one. Sorry, that's the Max 333 or something like that. This doesn't replicate a switch, but it does mux analog channels, and it works in ± 15 volts. I'm running out of them. I used to have a ton of them. They were for a brain imager, because your brain, believe it or not, as smooth as it is, your brain always uses approximately the same amount of blood. And so what it does is it divvies that blood. There's a whole vascular structure behind the brain that constricts or dilates in order to regulate the amount of blood that goes through different parts of the brain. And so if you measure from, for instance, the frontal lobe, which is exposed, no hair, sometimes there's no hair like all the way up. Frontal lobe is the last part to evolve, so that contains our complex reasoning and emotions. sort of hardware. We don't know a ton about the structure of the brain. We do know a lot, but its plasticity is something that evades us, right? So if you wanted to, for instance, see what the brain was up to, there are frequencies of light that bounce off of blood, and they go through bone and flesh and stuff. And if you want to see how much that blood is oxygenated, there's another frequency for that that goes through bone. So, two frequencies, a whole bunch of optical receivers with amplifiers in them, and you can sort of see whether or not somebody is thinking hard about something. The thought, it was kind of a solution in search of an answer. So one of the thoughts is that it could be like a lie detector, where if you lie, you're also thinking about the truth. So there's increased activity in the front of the brain. I don't know to what end that ever came about. The only problem is you can't stop the brain anything but permanently. So you can't really get a good baseline. You can have the user meditate and try to get a baseline with that. It's just tough to calibrate the hardware. But anyway, so I was moving that over to a surface mount design. Back in the days when surface mount was still a little bit novel. And so I bought a bunch of Max 308s and 309s on their company dollar, on their grant money dollar, and that project never came to fruition. And so it kind of fell on its face, and I was left with a whole bunch of Max 308 and 309 hardware. They're really cool, could be really cool for synthesizer stuff because they work in those voltages. I can mux around analog stuff. I still don't know to what end. Maybe I could do like a weird sequencer with them. But we've been using them in projects for quite some time now, and so my supplies are starting to run low. All right, so we have 2 analogs, and then we have how many analogs to implement? 1, 2, 3, 4, 5. 5. 4 and 5. 3 and 3. Wait, 1, 2, 3, 4, 5. We would have 6 and 7 if we had that switch panel, but we have 5, so we could fill one up and do one on the other, or we could do 3 and 2. It'll probably be 3 and 2. We can do one of these on one side. So this one is on this side. And then our pins are going to be ground and an LED. So ground, LED comes over here. So let's go over here because the digital pins will be on this side. I guess it doesn't really matter. Okay, so ground here, LED here. I'll just put a buffer in there, and I need to make sure it's pin, ground, and then, okay, so that's actually a ground pin. Might be helpful for me to just put the ground pins, the grounds, and then we'll put this one here and this one here. And actually, what we should do is label them later. We'll label them later. I don't need to label them right now. We can just make a serial print of all the different analog reads. I think cops should stop trying to invent. These weren't cops. These were researchers. They were just looking for like an application for this thing. My brain might be using a ton of blood, but it doesn't feel like that. Yeah, I know. It's, you know, no matter what, people's brains work about the same amount, I think. Brain works better on cookies. That's the funny part. All of this resource and water going into AI, and yet a puddle of meat basically running on a chocolate chip cookie can run circles around it. Let's see, the one with 1, 2, 3, 4, the one with 5 pins, this is the one with 4. The one with 5 pins has 1 analog on it. So we'll take that 1 analog here and we'll put it on this side. So this will be the 1 analog because this one has a bunch of digitals. And then this one will go over here with these 2. It'll be the 3 and 4 of this one. So this, and then those 2, and then there's a button. So I need more jumpers. I've got a whole pack of them right here. Just try to vary the colors so that you can easily trace all of your connections. What color did I do analogs with? That would be, yeah, the green and violet, I guess. Yeah, no, the lie detector, and if you ever get a polygraph, don't tell them you know this. The lie detector is never admissible in court. It's not real science. It does not work on real principles. What it does is it measures hibbity-jibbity, weirdo stress factors that are not necessarily, which one went to which one? Hold on. That are not, you know, repeatable, or they're just not good, right? It's not admissible in court. It's not a real test. What they do is they use the lie detector as the good cop. So they have, or sorry, the bad cop, not the good cop. The lie detector is not the good cop. They don't go, this technology is so wonderful and it likes you so much. No, what they do is they go, hey man, oh man, you know, I know what Vegas is all about. You know, you get the guys out there and you just lose control, man. It's, you know, it's okay. The lie detector's off. I turned it off. We're already done. And then they get you to admit stuff afterwards. They go, that, when you said that, there was kind of a weird reading on this thing right here. I wonder if you could elaborate a little bit. Maybe you're not quite being truthful with me. That's what they do. They get the lie detector, they get the technology to be the bad cop and get you to admit wrongdoings. There's no looking at the data later and going, we don't like what we see. What they do, and especially in government, what they do is they fail you the first time. And when they fail you, if you're guilty of something, you're not going to want to come back. You're going to not pursue that job anymore. It's pretty evil. It's pretty evil. My one of my uncle's whole office was going over to doing government work, and they all took the lie detector and they all failed it. And I went, that's fine, just go back, you'll be fine. Just head on back, you'll be all right. And then they all passed. Now it's 4 and 3. What was I doing? Oh, wait, there was only one analog from which one? I'm trying to hook this up without thinking. From the one with 4. Oh no, there's 2 analogs there. There's one analog from this one. Oh, okay, so that one, this one is actually a button. I did 4 and then 1. That was dumb. Move one of these 2s over. All right, this is a single button. And then the next 2, and I need more wire colors out of this thing. What's up, Fearless? Have we had YouTube chatters? Yeah, okay, we have. Kavorka was in YouTube. Okay, cool. Just making sure. Every now and then I gotta come up for air and make sure all my equipment works. And then these 2 are the binary stock position. I don't know what they decided to do. This one stock with binary instead of using one wire to transmit the location. But what I'm doing is I'm setting this up as a puzzle, and we can figure out who's connected to what later. I can note it down, but it's more fun to do it experimentally. Okay, there we go. So that's everybody hooked up. Let's just get this tightened up. The only thing that could potentially shoot me in the foot here is if the Pico Pi does not have input pull-up ability, in which case we'll have to move everybody in and put a bunch of resistors to power. And the problem is we've got a 5-volt rail, not a 3-volt rail, so I might have to switch it to a 3-volt rail. It's going to be a major pain in the butt, but I think these are input pull-up compatible. I've done a bunch of prototyping lately, so I treated myself to a whole set of SMD breakouts. Pricey, but they're so nice. Yes. I keep those SMD breakout boards around, and I find those to be the way to go, because that way, if you run into a chip that you can't put on a breadboard, you can use these breakout boards to adapt it over. And I've used them for all kinds of weird stuff. Like if I have a 2-row thing that I need to plug in, I can get that over to the breadboard or whatever the hell that thing is. They're not specific breakouts to the thing. They're like a breakout for a specific chip. But I also have that 300 sensor breadboarding kit. That helped me a lot. Those used to be cheap. I don't know if they're expensive now, but yeah, like breakouts like this to use a very advanced chip on a breadboard. Very, very useful. A lot of my breadboard stuff is actually in the development for the mixer. But then again, Julian found the exact mixer with all the features that he was looking for. Some, I think, Scottish guys, maybe they might just be British. I don't want to. You call them the wrong thing. They always hate that. They made the exact mixer that Julian was looking for, and it was way less hardware intensive as my design. My design used a lot of stuff, and it had like a high quality headphone amp. Theirs was just like a singular amplifier. I don't have a cap on this. It was like a single amplifier chip, and I don't know how they pulled it off. I do not know how they did it. We are fully realized and hooked up for a Mux test, aren't we? I think so. Hold on, I'm just looking at something. Yeah, I think we're ready to go. These will all have neutral values, but then they will have their different positional values, and then they'll also have a disconnected value. We'll have to see what those are. All right, so this is going to be Arduino coding. Can we put a counter up as to when the first question about AI comes up? Bother, why don't you just use an LLM? Because I have a functional brain between my ears. Okay, tools, hardware, board, Raspberry Pi RP2040, Raspberry, Adafruit, Bridge Tech. What the fuck are you? What are you, board? Raspberry Pi Pico, iLabs, Seed, WaveShare, generic? No. What do we use in the past for this? UC. Sometimes the best is you don't need that thin bother. It's using. You don't need that thin bother. It's using a ton of blood. That amount of shade just caused a nuclear level, fallout level blackout. What are you talking about, huh? Rad Scorpion. Let's see. What was this thing called? I forget. I'm gonna look at. I think it's just Pico Pi. Yeah. Instead of like vaporizing water or poisoning a local water supply, I can just eat a cookie. Where are the other ones of these here? Raspberry Pi Pico, copyright 2020. I mean, I guess generic RP2040, but is it on here? Is Raspberry Pi Pico on here? Oh, yeah. To be smart. Okay, so I don't really think we need anything specialized on this. Up, down, left, right, wheel, IO, in, out, wheel, stock, LED, wheel, stock, and they're on different pins now. And we can determine what they are later. We can get it wrong, and then we can reassign stuff. Constant, uint, 8, actually define. Or should we do that, or should we, no, maybe I should use the 8 T's here. But if I assign them constants, that shouldn't be, maybe the compiler will get it. I think we probably should use define. That's not, is that not how? I have to look up some old. You're using the phone keyboard. Oh, I'm always shocked about the people that watch me on keyboard, on phone. Man, listen, my brain is not working today. Open. This is just a silly test of this thing, so. Yeah, you know, it's been a little while since I programmed anything serious, so I'm just kind of refamiliarizing myself with this. I used to be able to just like bop out code, and I'll get back there. I just need to, you know, get some of the cobwebs out. This isn't, no, file open. No, this one's too rudimentary too. I'm looking for something that I've coded that I, you know, understand. It's not opening. Why don't you use MicroPython? Because I know Arduino? I mean, because I don't want to? Yeah, these were bytes and input buffers, and then I didn't have timer tick, huh? Oh, this is for other, this is for Linbus printing. C is just easier. It depends on what you're spun up on. C is better for speed and memory. I don't know how much we're going to be needing the speed of C code here, but it does sometimes get down to very minor timings, and we might measure the timing with the oscilloscope. All right, I'm not going to use defines then. I just feel like I'm wasting memory when I do a constant like this, instead of doing it as define. I think it is just define. Define IO wheel stock 14 like that. But I don't know why it's highlighting in green. That's gonna, oh, and then none of that. It's mini define, huh? Oh, do I do it lowercase? Maybe that's it. Define, and then, okay, what else do we have? Up, down, forward, back, that's the steering wheel. The indicator, high, flash, so we have headlight, flash. We have headlight, high. And, oh, that's the same one. So headlight. Oh, no, that would be flash, headlight. And then we have, oh no, that would be indicator, indic. And yeah, high headlight indicator. And then we would have LR indic. And then we have speed, speed wipe. Oh, and then actually, wait, on the indicator, we also have the button, which is for some reason labeled BC indic. And then on the wiper stock, we have speed of wipe and then level of wipe. Level, I'm going to do level 1 and level 2. 0 and 1, level 0 and level 1. We'll zero index that. Or, you know what, I'm just going to call them the binary pins. Binary 0 and binary 1. Wrist is a little weird. This is not a good typing position. I'm working on a personal project. That's awesome. Currently trying to get back into making PCBs. Dry film is hard to get right. Oh, making the PCBs yourself. I've talked at length about this. It's too annoying and too easy to do batch processes. The batch process works so much better, but dry film is hard to get right. Not getting the resolution I want. I tried using oiled paper, but it spreads the light too much, leading to a blurry image. Huh. I mean, you could go the route of making your own silk screens, and then you could silk screen it down onto the substrate with something that's more crisp. Although I guess silk screening is on the edges can be, well, silk screening can be very accurate, actually. But it's easier to print the thing, so yeah, I don't know how that works. All right, and then the button on the windshield wipers is the washer. So define, wash, wipe, which you all should be doing. Get up a day. Okay, wash, wipe is there, and then define. So these would be stock pins. Stock, yeah, just the stock pins. I don't have the stuff for that, but maybe I should get it. Actually, wait, these are the variables that I'll have. These are actually the variables. The pins should be the defines. Pins, stock variables. And then these should be uint 8 T up down wheels equal 2, which means they should be in lowercase. I gotta retype all these. Wait, I don't need to retype all of these because these are just the pins. The pins will also have variables, but they'll have analog and digital variables. So I'm gonna bring that over to there and make this one back into a define. And actually these should get, yeah, those should get pins, those should get variables. And I have them organized as pins. The variables will relate to whatever pin they're on, but it's going to be lowercase. And they'll initialize as zeros. Because we're not getting positions yet, we're getting values from the variables. So I'll just call them the same thing, only lowercase. Don't have the stuff for that, but maybe I should. Yeah. I've been wanting to silk screen. It's, I mean, I've seen it done before. I don't know if I would call them good. They were very rudimentary, like Radio Shack level etched boards that didn't get solder masks or anything, so I wouldn't trust Bother to know what he's talking about in this particular subject. So much typing. So it's basically define and then the stock that it comes from, which is pin by pin. Speed, binary 0, binary 1, and then wash wipe. Because we're just going to print them all out. You can do 0.3 millimeter using transparency sheets, laser printer, and a photo mask. That's cool. Yeah, that sounds like a lot of fun. It sounds like I would want to make a whole lot of jigs in order to get that done without annoying me. These could be binary. They don't have to be U and 8T. I forget I forget how to define that. I forget how to define that. I'm forgetting a lot of programming. I don't know what's going on with me. Bool. That's right. Yeah, let's make these into bools. Bool! Like spool. Spoolio has been streaming again. Spoolio is one of the members of Funhouse that got out early. He's like, I'm out of here. This is crazy. They got out before all the drama. Spool's awesome. I've seen him hanging around Rabaz's stream. The buttons too. Buttons would be LED for the wheel is an output. Oh wait, but those are, yeah, these are variables, right. The wheel LED status is something that we don't need here. Although if we do want to check against where it's set already, there is no Dana, only Bool. Are you the keymaster? Okay, so wiper speed, that's an analog. This one's the digital. BC is a bool, whether it's pressed or not. That's all we're gonna display. We could use possibly a debouncer on that maybe. Even at the speeds of the analog read that we're doing, a debouncer might still be necessary. Left, right, that is a voltage level. Headlight, it's BC and flash would be the other one. Did I do that one? Or wash? So that one's a bool. It is a fool. And then up, down, in, out. Actually, it's in, out, headlight, left, right. Wait, we've got another. Oh, it's actually up, down, UDIO, and then the other one's 1, 0. Okay, it doesn't like that. It's like an on-off, but we'll just make it the fuck button. And that's U and 8T because it has 2 voltage levels. Headlight indicator, as in high or flash or off. 3 states, 2 resistors, 1 wire. Left, right is the same deal. BC is the mystery button on the end of the stock. Yeah, okay, I think that's everybody. So up here it's UDIO and fuck. Okay. Okay, there. So we've got, those are all gonna be assigned pins. I can figure out which one's connected to which. I'm detailed enough that we can maybe actually put that to actual pins. So let's do this stock first. The blue wire is pin 5, and that's UDIO. Blue wire coming over to this header. Where is the blue wire on this header? That would be this one, the green coming down to here. Oh, right. So these aren't going to individual pins. They're going to be loaded up by the mux. So that's not how this works. Wait a second. I'm losing my mind, chat. That one fits very loosely. I don't like it. Okay, so instead of that, we're actually going to be plugging them into these. And so I guess I just need to relate these over because it's A1 and A0. And then we still have all those variables. But the pins, it's going to be selector 0, selector 1, well, A0 and A1. Common, what is it on the chip? Com A, com B. Common A, common B, and now we actually have our digital pins. So that would be the LED on the wheel. And then we have the BC on the wheel. Then we have bin 0 bin 1 wheel and define, sorry, that's wipe, define wash wipe. There we go. So those are our physical pins. So selector A0 and A1, which are digital. Okay. Those are outputs. And LED. Okay, look at how organized we are. Common A and common B. Are on those sides, com A and com B. And in my case, the pins are common A goes to 27. Okay, so this is, yeah, this is how it is right here. And A0 and A1 are going to pins yeah, and the very last pin is A1 on the left side. A0 is on the left side. The first pin goes to the right side. So it's actually the other way around. Somehow that worked out. That worked out somehow. So 20 and 19. select A0 and A1. Oops. No. A0 is pin 20. This one is 19. The LED for the wheel, I think, is the first. Why that pin keeps unplugging? That's very annoying. Hold on. Okay, and then this stupid pin just does not stay plugged in. I don't know why it's so bad. Oh, because it's not plugged in all the way. I see. Oh, there we go. I just plugged it in all the way using that pin. Neat. There we go. That'll stay on. Okay, so let's see. The LED is on the red wire, which goes over to here. And the red wire is this one, which goes to our next digital pin. So 13. Oh, that's pin 1920. It's actually pin 15 and 14. And then the LED is 13. And then the wiper washers are on pin 2 of the wipers, which is... Hold on a second. I'm going to get this. White wire here. White wire goes to... There's going to be a ground in the middle of this, isn't there? Yeah, 13, 12, 11, 10. You know what? As I plug them in, I should be noting them down in the code. So I banish all of you digital pins, except for the one that does the LED. So now we find the one for the wipers. The wipers are a 4-pin, no, they're a 5-pin connection. The white one is a digital, and that goes to the next pin. So 13, this is 12, pin to 12. And then we've got 2 pins that are going to be the binaries for the wiper speed. And those are going to be on... Wait, is that the white wire? It's not the white wire, it's the... No, yellow and... Okay. Yeah, it is the white wire, and then that one is for the analog. So the next one down is for the analog on this one. And then it's yellow, and these are the 2 binary ones, the yellow and the white, or yellow and blue. Because those are... No, it's actually yellow and green, are the... Hold on, I'm getting all confused. Connect the fart box. Oh, connect it to the fart box. I mean, you know, I could when I get everything into Node-RED. Yeah, we could bridge that gap. I'm just getting very confused about this stuff. The analog one would be the 3rd pin from the wipers, and then the 2 ones that are next to ground are for the booleans. So the 2 ones that are next to ground on this thing over here are yellow and green. Probably meant for that to be another way, but yellow and green, which are straddling. So this one, and then, really the green wire? Did I not do this properly? This one's a button. This one's an analog. So the blue wire is an analog. So I've already messed that up. Blue one, analog. Is that what I just hooked up? Did I really? Yes, okay, good. So this one goes to the green wire, which is one of the binary ones. We'll call that, well, it doesn't matter which one's which. We'll figure it out later. But that would be the yellow and the green. So this one's green. Green will go to our next, and then yellow to the one after that. And actually 0 will be the top row and 1 will be the bottom row. So that's actually going like this. So the next one is binary 0 and then binary 1. So 11 and 10, which are available. So 0 goes to the top one, which was 11, and this one's 10. Oh, we're getting there. We're getting there. The BC button on the, not on the wheel stock. BC is on the indicator. BC indicator. Did I get that right down here? Oh, that's variables, but that's, right, the button doesn't need a variable. Wash wipe is another button. Oh, I guess I do have BC. You know what? We got to load it into the variables. So yeah, that actually is fine. Oh, this is killing me, you guys. BC indicator. And I put that on pin 9 after skipping a pin. So BC indicator would be the only one that I haven't plugged in yet. And that's the last one that we need to define. And so I just put that right there. There we go. Okay. Whew. We did it. We did it, chat. We did it, Reddit. Yep, those are plugged in properly. Okay. COM A is 27. COM B is 26. And we check that over. COM B is on the opposite side of the chip. COM B is the orange wire that goes to the lower pin, which is pin 26. Okay. Yeah, we're making progress. We're putting together our program, and so one of the harder parts is figuring out what pin goes where. We have all of our analog and digital pins defined now. This should be correct, given that I've taken copious notes of everything that's going on this thing. So now I need to get into the program. Basically, we need to load all these variables up, and then we need to serial print them all. And then we'll be able to play with the stocks and see if everything's working properly. From there, we then load in CAN bus communications, because that's basically if something changes, we'll affect it with CAN bus. We'll communicate it out with CAN bus, rather. That's the idea, anyway. All right, so these need to be like totally rewritten. So first of all, I need to pull up everyone. So I'm going to need a bunch of pin modes, and actually we'll just cut and paste this and modify it. Because essentially everybody should be an input pull-up, except for the analog pins. Actually, those shouldn't. So these two should not be input pull-ups. But actually, wait a minute. We'll just delete them from that, and then I'm going to paste it again. This is going to get messy before it gets clean. Pin mode. COM A input. Pin mode, COM B input. And the rest of them we do input pull up, and the LED we do as output. Oh, actually these three are outputs. output, output, output. And then the rest of them become input pull-ups. Wait. I really hope the RP2040, I think it does have input pull-ups, pretty sure. Oh, that's an interesting thing. COM A and COM B actually should be input pull-ups on the analog pins. Yeah, there we go. Okay. Whew. Okay, we're getting there. We're getting there. We're getting there. So yeah, we've got our variables. We've got our pins, analog and digital. We've got our pull-ups for digitals, for analogs. We've got our outputs. And then we can write the LED stock to be high until we deactivate it with a 1 or a 0. Although in this case, we are not going to be activating it yet because we want to look at what numbers are coming in. So this stuff is not what we're looking for. And then I guess what we need to do is we need to do, how are we going to do this? States for everybody. I need to figure out what analogs are plugged into what inputs so that we can read them individually and then load them into variables. And once we load them into variables, we can do the serial printouts on them. So what is my program going to look like? Well, first we're going to assert 0, 1, 2, 3 onto A0 and A1. We don't have a 4 because there's no fourth state of this thing. It's 2 and 3 are plugged in to the sides. I think, yeah, 2 and 3. We would possibly have 4 and 4 if I could find that switch that I was looking for so long. What is that? Looked like a bug. I thought I saw legs coming off of it. No, that's just the text. It's just a little offcut. It looked like a mite. Okay, so, oh boy. This is a lot, huh? I could have a counting engine, or I could just assert the different values of the things that I want and then read into variables. And I think that's what I'm going to do is we're just going to do the forced. I'm not going to do anything more intelligent than just write it directly on the loop. So we're going to do it the big dumb way. So I'm going to start with state 1, or rather read 0, digital write. What should we do this thing again? Cell A0 low. Read 0, 0. Read 1, 0, 1. Read 1, 0. Now I could make like a read function. That's how you should think about this stuff in programming, because we're writing in C, C++. It's a C with a bunch of little functions in it that help us do Arduino things and help us learn Arduino, which I would say is not microcontrollers, because if you go to the big boy microcontrollers, you have to write everything different. But then Arduino defined everything microcontroller because they were accessible to people who weren't turbo super electrical engineering nerds. So in this case, whatever, learning the Arduino parlance, all the little functions in it is fine. But the way that you should be thinking about programming in C-ish kind of things is by having functions that do all of your work. So my loop should look like a list of instructions, and then my functions could be other, larger algorithms, and then the functions that those functions use would get you down to the nitty gritty. That's kind of how I think about it. It's like the forest for the trees. But we're starting here programming the grass manually and loading stuff in manually. And then when you start to see those repetitious structures, you can start thinking of those as functions. How would I make read into a function? I would make a function called read analog, and then I would have a uint for t going into or a uint maybe two booleans. I don't know. You can really boil it down into just like its component parts. I mean, you could also just make a uint8t, but then you could have something where you'd call that function that would put the digital writes on the outputs, or even load registers and put the assert values on the registers. But in this case, I'm just doing it this way, because this thing needs to iterate through all of its inputs, write it to the things, and then make a packet. Digital write and digital read are already big enough functions. The hardcore microcontroller people hate these things. They hate digital write and read, even though it's been found that even though these need to execute a couple instructions to run, they're still super fast. They've been boiled down by the compiler. But, those microcontroller nerds will always find something to hold their nose up at and say, you're not good enough for the level of how we do things. But it's like, I don't need to be. My big dumb microcontroller can do big dumb microcontroller stuff like a big baby with a big diaper on. Like, it doesn't matter. Yeah, you should be writing an assembly. You should be moving bits around. I can't believe you typed the same variable 4 times in order to do something. Just putting it in there. And then we need dwell time. So these are settings. Dwell milliseconds. And then there's, this is just so when you're scrolling through, you can find it easily. I ascribe to using this sort of notation loosely. Not trying to make an Excel document out of this. Please don't tell me about errors. Don't do it. Don't do it. Don't be tempted. Part of programming is getting it wrong. And I would like to show that on this channel. Dwells a settling time for the analog inputs. The max 308 and 309 have a certain amount of time that things need to settle before you start reading the stuff. Ooh, this is bad. My wrist has been getting kind of sore lately, and the position of the keyboard is not good for it. All right, so read 0, digital write, blah, blah, blah. You know, and these functions will have different variables that go into it because we've got 3 switches that are going on here. So, yeah, it's part of learning, and it's something that I want to show because people who don't know programming and watch this, I need to be accessible to them. Okay, so now when we are in the 0, 0 position, what are do? So 0, 0 is the, and we can check the data sheet just to be sure, just in case. I don't want to have egg on my face. I like my face, not egged. A0 and 0, enable 1, on switch number 1. On switch number 1 is, I think this one. Oh yeah, number 1A, number 1B. Number 1A, number 1B. Number 1A and B are connected. Let's see, number 1A is this green wire, which goes to this blue wire, which goes to this blue wire, which goes to this right here. So that would be wiper speed. So number 1A, okay, hold on. Let's get my shit together. That's speed knob. And then wiper speed variable is all the way up here. Speed wipe. We're going to speed wipe. That's basically me playing D&D. Analog read. It's going to be speed wipe again, right? Oh no. Common A. Is that all caps? Yeah, com A. That's it. And then common B. Common B is over here. Orange wire. Green wire. Green wire right next to ground. Yeah, green wire right next to ground. Green wire next to ground is 1, 0. What do we call that? Oh, that was fuck, the fuck variable. Fuck wipe is equal to analog read com B. Okay, so now we have our structure. And when you have the structure, here's the whole, no. If you get the culture, here's the whole structure. We've had enough of the lackluster, trust us. We get the kind of games you can't rent at Blockbuster. That's a Del the Funky Homo Sapien song. Man, my manufacturing engineers would be lost with all those wires. They can't even build a DB9 cable with terminal blocks. This is just what I deal with, you know? I'm very familiar with this kind of stuff. I would rather, it would be much cooler, mind you, if I got like the modern stuff, but I think the modern stuff still does it. Because we found on like this one, they're still using 0.1 inch spaced cables. This one will be nice and easy to hook up because these are just like analog buttons. I guess that's the easiest way to do it, is to have pull-ups on buttons and stuff. And then this will communicate with like a cluster module that'll do exactly what we're doing here. It'll read all the analogs and stuff, and it might even have a mux in it as well. So all we can do is read 2 things per switch. We can just read 2 things per, and it's going to be COM A and COM B each time. Well, actually, one of them is going to be only one. Ah. And they're not all going to be speed wipe and fuck wipe. So, switch number 2. Switch number 2, which is the green wire, which is the blue wire, which is that one. So we go over to the drawing. Which one was it? That one. High beam, low beam. Up, down, in, out. Fuck. HDL, headlight. HDL indic. Oops, wrong one. And then B. Oh no, that was B. Wait a minute. That one was B. That one was B. We looked at B the wrong. HDL indic. And A is going to be we're going to need blue wire on this one. Wait a minute. Oh, blue wire on this one. Blue wire on this one. I believe that's IO. Yeah. Wait. No. Up, down. Forward, back. So A is UDIO. I mean, this is like referencing, right? This is what a lot of this stuff is all about. This is just how you do this kind of stuff. Is this thing going to send CAN messages? Yes. The Raspberry Pi Pico is perfectly capable of sending CAN messages. It's probably capable of being the entire broker for all the CAN messages. Don't you own the ticker printer for cables? Yeah, I could have labeled these end to end. It's just a huge pain in the butt. And I probably should do it because it's a personal project, and that's the best way to do this stuff, is you label those cables end to end, and it saves you so much aggravation. It's so nice when the labels are like that. We have an MS Paint document that's basically being those labels. The most simple accelerator will have just a potentiometer on a pedal, and they couldn't even wire that up correctly. It's driving me nuts this week. That sounds really aggravating. What we have is the BMW gas pedal, which has a very advanced like iPhone wheel style capacitance sensing disc sort of thing. So there's no contact, so that you don't have potentiometer wear to worry about in your car. That means that on the pinout, they made it match what the old pinouts were like. So it's literally just 5 volts ground and then 3 like I think it's just a voltage level actually. I don't think it's 3 potentiometer, 5 volt ground and then a voltage level. Yeah, this pedal is not magnetic Hall effect. It's actually a capacitance sensing disc. The new ones do magnetic Hall effect, yeah. Me playing with all of my iron filings in my driver's seat. Oh no, my pedal. Okay, UDIO and HDL, cool. So that's the headlights of the UDIO. And so now when we do 1, 0, so we've done 0, 1, and 2, or 1, 2, and now we're doing 3. 3 is only going to be 1, and that's actually only on COM B. And I could probably guess it depending on which one I haven't assigned yet, but we'll just to be thorough, we're gonna. Oh wait, not yet. Wait, what did I? No. That stays. This is the one that I change. COM B is plugged in. Let's just double check that. By COM B, I mean common B. Common B is an orange wire that goes to the green. Green goes to here. Yes, good. Left, right. In dick. And then PD is gone. Well, until we plug something into it. So obviously this could be done by something else like a table. In this case, we're reading Dicken balls. Okay, so now we've read those. Now we do the digital reads. Normally, I'd put all this stuff in a function, just so it would be the functions that would be in void would be analog read, digital read, serial print. In this case, I'm doing everything in loop right now, just because, and then later on I can make it into functions. All right, what are our digitals? Headlight, wiper speed, I'm being like super organized on this. You don't really have to be, but it helps me write a running program the first time. Do I have to do anything else with digital read? I have to put it into a variable. Oh, wait, these are the variables. Because we're just printing out all this stuff right now. We can do stuff with it later. Whew. And then we want to serial print it all out. How do I want to do that? If I have everything separated by bars, we could potentially use the graphing capabilities of the thing, or I could do them individually and we could just take a look at them one at a time, or I could try to put them all out all at once and we could just have a million billion lines of serial printouts, which I guess is the way that I typically do things, so I think we'll do it that way. First and foremost, we should probably just print out all of the buttons. So we'll start off with serial print. Let's see. BC indicator, binary 0, binary 1 washer. So BC. It's gonna be a big serial print. That's still gonna be crazy though. We'll just do it this way. Binary wiper states. Serial. This is not going to print the 0, is it? Is it going to print 0 if I ask it to print a 0? I think it might. Because it's two separate binaries that I'm trying to print. Will they only show up if it's a 1? I mean, yeah, I could filter it. That would be a bit of extra code, though. In Classic C, it's just 0, 1, and CS++, it's true Boolean struct. But then, but in the Arduino IDE, what it's going to do is it's going to, if it's a 0, it won't print it. Because if you have like leading zeros on a variable, it doesn't print them. But I think in this case, because I'm just outputting the binary, I think it will just give me a 1 or a 0. I think. This is just so that we know what the variables look like in this microcontroller, right? And this is going to be a total mess because when things have different lengths, all the numbers jump all over the place. I've had methods in the past where I've looked through the individual characters and tried to like sort it out. There's also a print function that I think I need to import something for that does that kind of stuff too. I forget it all. I used to know how to do that. Printf was my go-to for printing out a certain number. Yes, sprintf, but what do I do with that again? There's a way to use it. That would be useful for these next couple of variables. Sprintf. C library sprintf function allows you to create strings with specified formats. Sprintf, character, constant character, and then format. .2f. So they don't give you a lot of really good examples, do they? And this is a float. Yeah, but the placeholders, because the Arduino IDE won't print the leading zeros. You know, it won't be 001024. We're just gonna do it the. I'm just gonna do it the sloppy way. I'm just gonna do it sloppy. Wait, it wasn't the wipers that were like that. It was the wheel. Up, down, in, out is also wheel. My variables are all crazy. Up, down, in, out is 1, yeah, so... Okay, so... Headlight from the headlight from the indicator stock. That's speed. Whoa, 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 whoa. 1 second. Yeah, I gotta correct the variables. I got the variables kind of wrong. Wash, binary 1, binary 0, and then the BC button. Those are our digitals. Doot, doot, and these two. So that's 4 variables. And then left, right indicator stock. That's correct. Headlight. Oh yeah, because the headlight flash and high is an analog. Yeah, headlight from indicator. LR indicator. And fuck wheel and UDIO wheel. So UDIO wheel. Speed of wipers. Fuck wheel. UDIO. Headlight. Left, right. Okay, cool. There's so many variables. I mean, if it would come in cleanly, I could almost list these and then clear. Cosmo Quest! What up, Cosmo Quest X? Sorry, I'm just getting a code together. We're trying to read like steering wheel stalks. And the way that steering wheel stalks work is they try to minimize the number of wires. And the way that they do that is by having basically a resistor divider on the device. So as you select your different wiper speeds, you are essentially closing the circuit to a different resistor. And when you close the circuit to a different resistor, if you've got the other end of that pulled up to a power level, those different resistors will represent different fractions of the voltages of the total system voltages. So when you select right and left hand turn, that wire will go from a standing voltage, which is usually the higher end of things because it's connected to high, but then you connect a resistor to low, it's going to pull it down a certain amount. And so you see it 2 different voltages on these wires. That seems like a really clever way to save wires, but it is a major pain in the butt for us when we're trying to read the values coming out of these stocks on our microcontroller. And so the way that we do that is with an analog input. The problem is we only have 4 analog inputs. We have ADC 0, 1, 2. There's 3 on this. Wait, 0, 1, 2. Where's 3? Wow, we have a super limited number on this thing. And so what I use is an old chip. It's actually kind of an old one. There's better ones out now. I don't have those. I happen to have a bunch of these Maxim Muxes. And what they do is when you send them a 1 and a 0, basically a binary 0 through 4, 0 through 3, it'll close one of these switches and connect us to a common pin. So I can do 2 analog inputs and I can mux through the different analogs, give the voltage time to settle, and then read that voltage back as the function being executed. Now, obviously, I sort of know what I connected to what, we're putting together the code right now that's going to print it out serially, and I'm just going to carte blanche, like I'm just going to print it out as it is. That's just going to be what brings us to the end of the stream, because this is the easiest, although sloppiest way to do it. So I need, we'll just do this manually. After that, we have speed of the wiper, speed wipe, which is my D&D strategy, and then we do speed wipe, and we'll see all this changing the variables. This printout is going to be sloppy. It's the way that I'm coding this right now. I'm not using special functions in the serial printer, and I am just putting all of these out onto the serial print. As these variables change their values, the leading zeros are not going to be printed, which means there's going to be a different spacing for everything. So basically that first line is going to be steady. We're always going to be seeing BC indic is going to print over and over again and always in the same spot. The other ones are going to start moving back and forth. This is just putting it all out there at once. What I could do is I could put each of these on a different line. Maybe I should do that, and then I'll put like a clear at the beginning before the serial print. That's probably a better way to do it. Yeah. Print ln in all of the variable ones. Serial clear. So I think that clears the screen, and then we'll print them all out, if I'm correct about that, which I might not be. Yeah, I think this is a better way to do it. Okay, speed wipe. This is the fuck button. And then up, down, in, out. And then LR from the indicator stock. And we should probably organize these a little bit better. So any indicator stock stuff. Oh, and we also have these to do. Or did I include those? Yes, I did. So indicator, let's get the indicator stock functions together. It also helped me see if I missed anything. And then at the bottom, we have the wheel stock. I could actually put headers on that. Wiper, and then indicator. Indicator stock. BC button. Oh, headlights. Binary 0, 1. Washer wipe, wiper speed, wash would be the button. Zero and 1 would be the wiper speed. We'll put that a little lower. Washer first. And then the speed is the analog one. UDIO and the F word, and then the LED, it's just going to be on. Although we didn't assign, did we assign a pin for the LED? I don't think we did. Yeah, we never did anything with it, which means this needs to be removed. We're not doing anything with that because it's not that interesting at the moment. Wiper speed's the only one on the wiper spot. IO is the F-bomb. Up, down, in, out is, yeah, that thing. Headlight is high and flash and LR. So HDL, so for the wheel, up, down, in, out. For the indicator stock, we have left, right, and we should also have LR indicator, and we should also have HDL. This is the one that I missed. HDL, HDL. Doing a serial clear is going to help us out a lot here. Okay, indicator stock. BC, which is kind of like a mystery button, is a Boolean. Left, right, which is going to be analog values, and headlight. Wiper stock. You have wash when you wash by pulling it towards you. Then you have the binary of the stock position, with the bottom one being sprung. And I have a table for that. That's the thing that's sitting like right above me. And then you have the wiper speed, which is the wipe speed, which is a little knob. On the wheel stock, which is Mercedes, everything else is BMW. The wheel stock, it has an LED, but we don't have anything for that. We have the F button, which is an IO here. It's this and this. And that actually has 3 values, so that's an analog print. And then we have the up, down, in, out, which has 4 values, which is up, down, in, out. So that's the 4 directions that this stock can move. All right. It's so hard to fight the urge to sleep during the coding streams. Thanks. Appreciate that. Raspberry Pi Pico, 2 megabytes, no FS, 133 megahertz is fine. Small, I don't know what that is. RTGI, I don't know what the stack protect. Nope, no. Debug level none, USB stack is fine. Port, but it's not plugged in yet. And that'll all serial print. 9600, I could probably do 1152, but this should be kind of a slow program. I don't need it to be that fast. So maybe we need to put in like a master delay of like 100 milliseconds. And then we read everything and we'll just see if that feels slow. It probably won't. 100 milliseconds is 1/10 of a second. So, okay, so we've got all that stuff set up. We can check our program over. I can plug this thing in. I put away the cable. No, I didn't. I stacked it somewhere over here. Oh boy, where's my programming cable? Here it is. Yeah. All right, let's get this Duende plugged in. Which the superposition of USB applies. Typically, if your device is facing upwards, the USB logo should be facing upwards. Didn't mean anything by that except my brain can't handle looking at code for too long. I understand, but I also know that it sounds like, bother, you're boring me to death. Well, it's, yeah. And I'll put the serial thing up on the screen. We just need to see if this works first. Plug you in. Nobody blows up. Nobody blows up. Let's look for a port. Port 4 was already plugged in. I don't know what COM4 is. Huh. You have 2 devices. You have 2 board. If I unplug this, okay, so it is UF2 board. Plug it back in. You must upload your code to blow it up. I wonder if you could do that. If you could make a microcontroller program that not only destroys the microcontroller, but destroys whatever hardware is connected to it. You like heat it up somehow, blow up some of the support equipment. We're in nothing blows up territory. This is fine. HDL indic. Oh. Headlight from the indicator stock. Pin mode. Headlight indicator stock. HDL index UN8T is equal to 0. Jesus, this is a lot to go through. Hold on. Pin mode. Those are the analogues. HDL indic on inidic. Okay, that's the problem. Huh, they even have a corrector there. That's kind of cool. Check my work over. Looks like it got through it, and I wish I had. Oh, no, never mind. It does not have clear. All right. Print, serial value, serial begin, blah, 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 blah. Begin, end, available, read, peak, flush, print line, write, event. That's probably when you get a receive. So we don't have clear. I could put just like a bunch of lines on it, and hopefully it lines up. Yeah, let's just put a bunch of lines at the end of it. The problem with serial print in binary is that it truncates. It gets rid of the leading zeros on the variable. You remind me of one of my lectures in a good way. Oh, thank you. I appreciate that. Those TKF, the TKFers when they raid, those effers, they're always good. They're always a good raid for the kind of cerebral stuff that we do around here. I happen to not be hitting things with hammers right now. That's sort of a nice thing about today. We're having a nice chill Friday. I'm programming microcontrollers and emitting curse words. And when we get to the maximum allotted number of emitted curse words, our code actually starts working. Pretty neat. You need more hammer. I do, but I don't like to do that kind of stuff, although it's cathartic. So we're just going to do a bunch of print lines at the end. That's probably the best way to do it because clear doesn't work. It's a shame if we had like a screen that was displaying this, I could organize it nicely and put a little logo of all the stocks there and show them changing. That would be fun to do, but I've done that type of thing with synthesizers where you have the rounded edge boxes. We did look for the one switch. I do count that in the hammer category. That's true. That was hammer category. I was looking for a headlight panel that is on the E46. Well, this one was from an M3. It's somewhere here. I don't know where it is, though. And I was looking high and low for it. And I think I crushed my finger because it still hurts. Serial print line. And we're just going to do a bunch of those. So this is basically the hammer. This is big dumb microcontroller programming that we're doing right now. We're basically reading all the inputs, switching a thing, reading all the inputs, switching a thing. and then we print it out in the very basic way that hopefully we will be able to read and it won't like fly around on the screen. Maybe I can sync it up somehow. But this is the dumb method that I'm doing it with. This is not typical microcontroller stuff. If I was doing a lot of functions with this and it was going into something that was actually going to be like a useful piece of equipment, I would avoid using delays. I would make functions for everything. It would be nice and clean. And it would be a program that would run ad infinitum, and I'd use more microcontroller-y stuff. But right now, I just want to get the stalks plugged in, and I want to get this to work. I didn't write a single function on this. Because what I'll do is I can wrap all of this stuff up into different functions, and I can turn the serial print into a screen, and I could actually hook up CAN bus to this thing. You son of a bitch. You're not a semicolon, you're a full colon. How dare you call me a butt? Do. Almost there. Really? I did it twice. Oh, I did it in all the cut and pastes. Oh no. Cut and paste error propagating through my system. All right, that should be the last of it. I'm learning different bus tech, and CAN bus is up there. CAN bus is really cool. It's if we can get a 500 kbps CAN bus, what I'm hoping to be able to do is get all of the man baby toy buttons to come in on one side of Node Red on a Raspberry Pi, and then all the man baby HID devices that are plugged in. I'm gonna have a couple microcontrollers that can function as HID devices that will plug into a hub. So there's one plug, monitor and USB, that plugs into the computer and does the entire force feedback steering wheel thing, right? So if I get it into Node Red, I can have it so that I can just cross the wires and plug stuff in. And then I can also bring in stuff from my MQTT devices, so I can turn on and off lights, and I can have chat control things in the same way that the fart box does. So it can all be through that front end of the shop that's going on. Okay, so supposedly that uploaded, which means, son of a bitch. UF2 output size, opening serial port. Port not found. How do we do PicoPi? How do we do serial prints in PicoPi? Do I need to enable it in the tools? Whoa, what just happened? Did I hit upload by accident? Oh, I need to reset, and then maybe it'll find it. Nope. Jesus. I don't think this is how I do it. Huh. Yeah, I'm actually using the Raspberry Pi Pico in my main computer keyboard, which is a code 10 keyless, and we had to reverse engineer how that was hooked up. That was a hell of a project. It was a lot of fun, but yeah, port. COM10. Oh, look at that. Pretty clean. Why are they all over the place? See that? Okay, so I'm operating the fuck button. You can see it go down to 5. Actually, it goes in the same direction in both ones. That shouldn't be. What about up, down, in, out? Down, up, in, out. I see no discernible change here. We were able to get quite a bit of change on it. I'm starting to think that maybe... Although that one does do it. What about BC on the one stock? 0, 1, 0, 1, 0, 1. So that's working. What about, okay, washer on the wipers. Okay, that one works. Binary, that one's working too. So that's 1, 0. So it goes from 1, 1 to 0, 1. Yeah, 0, 0 is the top, 1, 0 is the middle. That works perfectly because that's on a digital pin. So yeah, the wiper stock is doing the proper thing. Wiper speed. I'm thinking that oh, but wait a minute. Do I need individual pull-ups for each one? I think I do. Yeah, I do, because that pull-up on the analog pins is not needed. I need pull-ups on each individual output. So I need to do like a 2K resistor or like a 1K resistor to 3 volts on every single one of these pins. Ah, son of a bitch. So I think we got it working. We just don't quite have it working. So in this case, COM A and COM B are just going to be input. And then these pins over here, those are going to need pull-ups on them. And I can't go over 3 volts or I blow up my microcontroller. I should have thought of this. I should have thought of this. If I were to do that, I would need to turn this into a 3 volt rail instead of a 5 volt rail. And then I would need to connect these pins there and there to 5 volts. So I'm going to unplug this. And let's see if we can get that done. I don't know if we can get that done quickly. It'll certainly be fast if I can get the rails configured properly. So this outer rail I'm now going to convert to 3 volts through the magic of moving this down here. Actually, wait, is it that second pin? Where's my pin out? VSys. No, 3v3 out. 3v3 enabled. Oh, I guess that's to disable the internal. So we want 3v3 out. So the 1, 2, 3, 4, 5 pins down. One, 2, 3, 4, 5. That one goes to positive. Hold on, I'll get you guys on camera in just a sec. This is the sort of important part where you try not to blow up your microcontroller. 1, 2, 3, 4, 5. So now that's 3 volts. 1, 2, 3, 4, 5. 3v3 out for analog. Okay, and then we go down, down, diggity down, all the way to these pins. And this one goes somewhere else now. The Max 309 will not operate without 5 volts, so kind of annoying. I need the jumper wire kit, some larger jumpers. We can get this done pretty quickly. This pin here. My beautifully made, very nice looking, clean Max 309 breakout board is in play. Which one was it? Was this one? That one going up over here. Going to the top taking this all the way to the top. Here, and then down. And then wire cutters. Here, let's go to this camera. This will all work in just a second. Just you wait. Luckily, we know the value of the resistors, so we can select a pull down that's kind of close to the values. So, well, I mean, it should be a pretty weak pull down because we want it to be able to, or pull up rather. We want it to be a pretty weak pull up so that we get good numbers on the thing. What's the resistor amount of the internal pull up on something like a Pico Pi? Like, what would it have been? How many kilo ohms are we talking about here? I almost said kilobytes. Imagine my embarrassment when I call the teacher mom. Was that not deep enough for this? Oh, you bastard. You bastard. You think 4.7? Willing to try it. We can also dive into microcontrollers and see what they flip it to, but what in the fuck? This is just, hold on a sec. There's like, it's running into something solid in there. There it goes. Okay. Okay, that's our first 5-volt connector. Our next one is going to that pin. That seems like a shorter wire. What do we even have one? We gotta make one. It's fine. It's easy to do. These tweezers are probably a little bit more accurate to do this. Oh, it's so close to the right length. If I could make the wire meander a little bit more, it would probably be exactly right. I hate it when I do that. I pull too hard on the wire and then I just straighten it out. Yeah. Okay, this here. I guess I could also go back and around over to the other 5-volt, but I guess we'll just jump back to the same pins. Yeah, it's kind of annoying that this is a 5-volt device and everybody can't just share 3 volts. Why can't you just share? All right, so there's our 5 volts connected. Now we need to find a bunch of resistors, and luckily I have a bunch of resistors, so we can just quickly get these cut to length using this cool tool that is $75. That's ridiculous. Piece of plastic. You can 3D print one of these. It's basically going to be the length of the resistor. We have 3 volts running to our rails now, and so now I need to take the inputs, not COM A and B. I need to take all of these, the N08s and whatever's on the max thing, which are connected to our voltage producers over here. We need to hook that up to some kind of a pull-up resistor. So in a 3.3 volt system, what do you think our input pull-ups are going to be? We have, let's see, the values of the resistors that we have on the other end, I do know. 300, 1.2, 1.3, 620, 224, 80 ohms and 1.3 kilo ohms, 8K, 6K, 4K, 2K. They're all going to react differently. They're just, different manufacturers. So, and they probably originally worked in a 12 volt system, and we have them in a 3.3 volt system. So let's just RP 2040 input pull up ohms. 50 and 80 kilo ohms. Oh my God. I guess we'll give it a 50 kilo ohm resistor then. It's like a real easy pull down, but it's going to pull way down if that's the case. If I do 4.7K, that'll overcome some of these other resistors. So I guess 50K. Geez, how many of those do I have? Actually, I probably got a bunch of 10K. That might actually be a better one to use. I want it to be above the maximum value of any of the resistors here. Don't I? Yeah, because it'll always pull it down more easily. 8K seems to be the largest. So if I make it 8K, then the 8K on the speed knob is going to make it half of 3 volts. Everybody else is going to be above that. $10K should be okay. Yeah, with an 8 and a 10, the 8 will overcome the 10 more and will get below that half value. But everybody else is above that. Let's just try 10K and just see what happens. That's what we're supposed to be doing today, is just see what happens. Where the hell are my 10Ks? I'm going through all these like frayed resistor holders. These are 1BK, 10Ks. Okay, these are 10Ks. And we need 5. I mean, I could do a different pull-up for each one, but let's just try these. I mean, 50K and 8K, 50K versus 8K would be the highest value, the lowest value. Sorry, everything's opposite. We'll just throw 10Ks at it. So let's get those secured. Make sure, take this one, bend them like that. So for that, I need 3. And once I get this done, we'll wrap it up. I'll mercifully stop streaming. It's a little bit longer today. What time is it? Not that bad. I might be the only person home tonight. Do I already have? No, okay, this is the 3rd. And then these are the last 2. Okay. I have to order out. My poor puppy dog. She's up there all alone. I mean, she's got every right to come downstairs. It's not like I don't have the door ajar. She does not challenge boundaries. If you close the door on her, she just is like, well, that's it. That's my fate. I don't know why she doesn't do that. The parallel rule. This tool, I wish I had a better name for it, because there is a link, and I should probably make that into a Nightbot command. There's a link for a 3D model where you can build one. I would advocate trying to implement the tapered pin that this has, because this thing will measure from inside diameter hole to inside diameter hole. So if you're using it for stuff other than breadboards, you can get a proper measurement off of the 2 plates. This thing, these tweezers specifically do not grip anything, and it makes it really frustrating to try to work stuff into a breadboard. These specifically. These are really good at building stuff, but 8K, 10K, 1/R. Oh, that parallel rule. Oh, I'm sorry. I try to avoid math on stream because, like, I'm not good at math. I know a lot of math, like a lot of math. Like I studied control systems in college, but I don't like using it. And so when it comes to like the basics, I took Circuits 101, but it was an 8 a.m. lecture. 8 a.m. at college is like the death of information. Okay, that's that. Get a measurement on this. Well, this one is shorter, but I can't do shorter. This is the size of the resistor. I guess what I can do is I can bend them directly like this, and that'll make the shorter jumper. because these have a little bit of thickness of the arms. I still have people upstairs, so I guess I'm not on my own. Okay, let's see. Move these two in. And this is kind of a tough area to work stuff into. I can't stand these high precision resistors, these 1% resistors that fly all over the place when you try to grab them with that specific pair of tweezer. These will just have to be above these wires. The problem is this introduces I want to say the F word, these thin wired resistors, and these thin wired resistors, they don't get pinched very well by the breadboard. But these are like all you can find to buy nowadays. We used to have big thick wires on our resistors, and they fit into these boards a little better. They gave more reliable connections. But now, if you build a big analog circuit using these resistors, even though they're precise, they are not necessarily connected everywhere you think they are. And so part of the breadboarding is like, wait, this isn't working. Let me push down on it with my hand, which is just unacceptable for this type of stuff, especially if you've got like an important prototype. All right, I think it's connected. Well, another way to get around this would be to put female headers on it and then plug the resistor into the female headers. That's another way to do it. It may end up close to 4 to 5K if parallel. I don't know exactly how you're wiring it, not paying enough attention. The 10Ks are going to positive 3.3 volts. The ones that I'm just putting in, and they connect to these stalks, which will connect to a variety of resistors, one at a time, that have different values. So I think 10K is probably a good value. Let's just spin this thing up again and see what it do. And I think I did something to the software, so I need to upload that. Oh, I got rid of the input pull-up on the analogues. That's right. Yeah, so we do need to actually upload that. So let's go to this. Plug this thing in. Choose the port. Port. I guess it's COM10 now. We've changed the behavior of this thing. Okay, now this should render all of these stalks readable. What is it doing? Oh, maybe I need to hold down the button, plug it in, release the button. Yeah, UF2 board. What, UF2 board? Let's see if that works. I think that's how it works. There we go. Cool. Okay. And then restart. COM10. Serial monitor. Port not found. It doesn't like the reset button. Unplug. Plug it in. Oops, this thing isn't plugged in. Make sure that voltage is plugged in. Everybody plugged? There we go. Okay, so if I take my left-right indicator and I turn right, LR and HDL are reversed. And that one isn't coming through. Okay. We may have to reevaluate some pinouts here. Oh, and it's also doing UDIO. What's up, down, and out doing? It's doing LR. So we couple issues. 60, 20, 120, 10, and then 200. Oh, looks like that HDL is actually this one. So we got 90 to 100, 150, 160, and then 200. Okay. LR is doing two variables somehow. I understand that one. And then the headlights are not represented. Okay. And then BC button works there. This thing, 175, 40, 130, 200. Why? That should be in order. That should not jump around. Why is that jumping around? 170, 40, 127, 200. The binary thing, that's a 1, 0 to do the spring down. 1, 1, 0, 0, and then resting is 1, 1. At least it's doing something. Yeah, I guess so. And then the washer is that variable that's doubled up for some reason. I don't understand. Oh no, there's wash. Wash is doing a 1, 0, yeah. So something got mixed up. And I totally get it. It's probably just me tracing the wire wrong. Me trace wire wrong. But I think all of our analogs are on analogs. What are the resistor values on the buttons? They vary. Boink. Oh no, the buttons are directly to ground, I think. Which begs the question, are they draining the microcontroller of all of its resources? I think, well, no, because it's an input pull-up. That's right, we've got an input pull-up. So whatever the internal resistance is on the input pull-up, this is pulling against it with just a direct connection to ground, which is how you're supposed to use input pull-ups. So where did I mess up the washer? I guess things are just plugged into the wrong things. But I need to figure out why that one variable is doubled up. Maybe because I cut and paste error. Which one is it that's doubled up? Because UDIO wheel is getting punched in there. And then these should be totally separate. Left-right indicator, HDL, UDIO. Speed, and then so when it's getting printed, I don't have the same numbers in here, do I? 12, 11, 10, 9, 27, 26. 9, 11, 10, 12, 13, 15, 14. No, that's fine. And then when I'm printing them, indicator, 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 wipe, 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 wheel, wheel. So then why is UDIO wheel is going to left, right. So UDIO wheel and left, right. Where are we? Left, right. Oh yeah, those get addresses here. Right, because they're connected to the mux. But then left-right indicator, yeah, that's UDIO. And then the left and right, oh yeah, 30, 230, 115. Okay, so that'll clear that up. And this is headlight indicator, which should be, that's not changing value. Headlight indicator is also doing the same exact numbers as UDIO. No, it's not. But it is changing when I go and do that. So something weird. Is it a hardware thing? Let's push down on that. Wiggle these a little bit. See, 50, 150, 30. Just wondering max min so you can come up with a better pull-up for the voltage rating available. Yeah, like 8K to 2K, you have 10 to 8, 10 6, 10 4, 10 2. So you're going to get 3.3 volts off of all the 8K, off of all an 8K button. You don't get about 1.5 volt less than half. So maybe something smaller to get more range. Yeah, that's again, yeah, I was thinking that too. Yeah, because you want it to pull down a much larger range. And I can do that individually for each one on this at this point. But which one isn't represented here? That's the washer. Up, down, left, right is on LR. That works perfectly. The fuck button works. Right and left are on. Right and left are affecting two variables for some reason. Why are both of them affected when I flip that? That should not be. Yeah, the wheel is moving when this one moves. I'm not doubled up on anything, although it might have a pretty weak ground. Give it a stronger ground and go to the other side of the board. Oh, you know what? That was on the floating ground. There we go. Okay, it's still being affected. Why does it go to 34 when I... Maybe this thing's overdrawing from the power supply? Does it affect everyone? No, my child's not affected. Chat. This is evidence. This is evidence of why BMW turn signals don't always work. I think we popped the lid on this whole conspiracy. Look, I'm trying to use the turn signal, but it's coming in as a headlight signal. And then it also affects the wheel position stalk, which is baffling to me. I don't know why it's doing that. I guess I didn't have it on a floating ground. I had it on the shared ground that everybody else has. Because, yeah, we did ground the other side. And those pluses are hooked up together. So I don't know why it's got all this crosstalk going on. There really shouldn't be any crosstalk. The wiper thing is not affected by it. And then if... Where is this thing plugged in? Those are all the buttons, and then the one analog is going over to here. Try to get a better connection for it. What if it disconnects completely? So 5. Huh. They're all jumping around when I plug and unplug stuff. I wonder what's going on there. And it could be that I'm reading them too fast. Well, anyway, I need to spend a little bit of time cleaning this up and making sure that my hardware is set up properly. And then I've got to find like an appropriate pull-up for these, because I think we could get a better dynamic range of numbers, which might mean that I want to find a different pull-up for each one. Because the two positional ones for the indicator are 300 and 1.2K. And then over here for the steering, 3.6, 1.3, 620, 224. Which is weird because under our 10K resistors, these are coming up with wildly different numbers. And then over here on the Mercedes, we've got up to 8K. So we can cater those a little bit to give them a more dynamic range of numbers. And that way all of our bins of available numberings can be spread out and it'll be a little bit more accurate. The only problem with that is that I have to be really careful about the pinouts. I need to make sure that my pinouts are exactly the way they should be. And they're on the right resistors. But I mean, this is a thing that I can just plug into the sim and keep plugged in. Right now, it's a bunch of wires, but if I know those pinouts, I can build a board that does this. We just need to get our proof of concept done. So this might be enough that we can do a proof of concept and I can try to clean it up later. I don't like that crosstalk. I don't know what's going on with that. We've got 10K pull-up resistors, so the current should be very small. There should be a very small amount of current indeed. So I don't really know what's going on with that. I mean, yeah, I don't know. The digital pull-ups obviously work perfectly. So that stock, the up and downs work great and all the buttons work great because it's built into the Raspberry Pi. The analogues, unfortunately, I need so many analogues. I can't just plug them in directly. I have to use a Mux. And because I'm using an old Mux, it doesn't have any internal pull-ups. And so I'm using these fucky 10K resistors. And they might be playing with the fact that 3.3 volts goes all the way out and around here. And we have our analog reference 3.3 volts. So that may be being affected by our pull downs. I wonder if that's the only 3v3 we have available to us, though, is 3v3 out. So the Mux needs settle time. We have it at 1 millisecond. Maybe let me up that settle time. 1 millisecond, it said microseconds in the overall thing. Why is BC indicator shifted to the left? Oh, all the other ones have a space ahead of them. I see. I left that in. Yeah, so let's just go back and just clean that up just minorly. Close this. So in the serial prints, I can get rid of all this stuff. And then we swapped the pins already, and then I need to do a longer dwell time. So delay 100 before it runs, but then our dwell in milliseconds, we're going to make it 100. I'm going to go for more 100 millisecond delays, and we'll have to minimize that on the final system. All right, C Strachan, thanks for stopping by. I appreciate the help. Okay, so what I need to do: unplug this, hold the button down, plug it in, let go of the button. I think that's how you do it. UF2 board, uploader code. Maybe the additional dwell time will help settle the crosstalk. Flashing RP2040. Wrote a bunch of bytes. Tools, port, COM10, and then it's going to yell at me. Yeah, so unplug it. Hit the button, plug it back in. I don't know exactly how I'm supposed to be doing this. Wait a minute, and then open the port. So now it's really slow. You can see by the rate at which the numbers are flashing. Do we still see crosstalk? I see much less crosstalk. Wash your hands, turn the page. That should be headlights on. Left turn, right turn. It's all crosstalky. Look at that. And the left-right indicator is still, it is doing stuff. But why is the headlight indicator jumping around like that? It really shouldn't be. How the hell would there have been crosstalk in my system? This one's going to that side, so it's the side with only two things plugged in. So they're both from the same indicator. Oh no, that's over here. Those are the three. These are the two. Those go over to this one. That's fine. Seems pretty, that seems much more steady. This one, 130, 230, 4. Yeah, great. That one's perfect. This one, 1, 0. The digital ones are fine. Those work perfectly fine. Speed. So bottom one, 5, 7, 10, 11. That could definitely be changed. I could make that a little bit more clear. When the difference in the numbers are single digits, that's very close voltages. But it is steady enough, and it is the only one that's changing right now. But then when we get to the indicator stock, everything's all messed up. You can see, like, well, that is actually working a lot more consistently. 20. It's still 20 though. Oh no, we're looking at left right, which is stuck at 250. No matter what I do. High beams off. High beams permanently on. Yeah, it seems like it's not getting a ground, or something just isn't. I mean, the pinout's fine, right? Yeah, pinout's fine, but that one has two. Oh, one thing unplugged over here. What unplugged? My ground pin unplugged. Back on ground. There we go. Okay. So 12. 230, 240. Yeah, 240 versus 230 is, I'm gonna need a little bit more range on that. Right, 112, neutral 250, left 30. Okay, it is working. It is working. Yeah, right is 111, 240 is off, 30 is left. Pull for flashing brights. That goes from 240 to 212. Push to turn on my brights. That goes to 212 again. 220, 240. The difference between the two should be, well, with the 10K resistor pulling it up, I guess that doesn't quite do it, but it's 300 and 1.2. So these two are about the same in terms of their resistors, and so it's got a 10K going up. Yeah, it does work. Giving it a little bit more dwell time has sort of smoothed out our numbers. I can pull back that dwell time and make them come in faster, because right now it looks pretty instant, but it's kind of not. And I need to change the resistor values so things are a little bit more definitive. If I put like a 50K on there, I don't think won't they be closer together? But 50K is really weak, so if we're pulling it with a 300 ohm and a 1.2, will that give us a better range? I think so. I don't know how electronics works. I need to run some equations. All right, anyway, so we got it working. Our inputs are going into this thing. The only thing left to do, obviously, aside from all the little bits of tuning to do, because these are analog, and analog is always annoying, is to cater our resistors a little bit, figure out what our variable numbers are going to be, associate those with a state, and put those into a packet that's going to be transmitted on CAN bus. So when the states change, it'll go, states have changed. Throw out this packet. Hey, my states have changed, and then we'll receive that with the Raspberry Pi. So those are our next steps on this thing. That was pretty good. I mean, we got We got our whole breadboard test set up. We know the muxing works to give us additional analogues, which means we can use a PicoPi, which will be able to very quickly do the CAN bus stuff. This chip helps speed up CAN bus for the receiver, but for the transmitter, well, actually, because this thing will be receiving, I don't think we have any backlights on this stuff. We have backlights on the other stuff. We have like, you know, running lights or whatever on the other ones. We have the LED over here too to turn on and off. So we will have packets coming back in telling us to do things. All right, so that being said, I need to go walk my puppy. She's just been to the groomers. She's probably traumatized from getting her nails clipped and getting a haircut. I probably need to go to the groomers. That takes on a totally different meaning when a human says that, doesn't it? I should go to the barber. That's what I should do. I will catch you guys next time. Next time, I don't think it'll be, I don't know if it'll be tomorrow. Probably should do tomorrow. We probably should stream tomorrow. So I may stream tomorrow. I'm not going to make any promises. Until then, you guys probably, let's see if there's a channel that I want to throw you guys at. I don't think there is. Cosmo Quest X rated today, which was very, very nice of them indeed. That's awesome. I got to figure out what was going on in space. Sark is doing 7 Days to Die, which is actually kind of a funny game. Gonad is on playing My Winter Car. So if you feel like going somewhere that's another maker, he may or may not have something going on the printer. I'm not sure. You guys can go there. YouTubers, YouTube is just like not a community, I guess. We don't have raids. And also, I have 2 concurrent viewers, so... It's probably just Madam You over there keeping the lights on. Thank you guys so much. I really appreciate all of the fanfare, and I will catch you later. I'll probably be on Discord. Here's the old end card just to put a Discord up on the screen, just to put that link up on the screen. My Blue Sky got hacked. I'm hoping one day I'll get it back, but my hope is it's dwindling to get my Blue Sky back. Maybe one day I will. But I will be back more than likely Tuesday, maybe tomorrow, but probably Tuesday. We may do a hashtag AutoCAD ad where we design some of these wedges that have to go into the simulator frame. But until then, have fun. I'll see you guys later. I'll be on Discord. Goodbye.